Imagine something so massive, so powerful, that not even light can escape it. Now, picture that force moving through space at millions of miles per hour, a predator without a home, a cosmic wrecking ball that defies everything we thought we knew. Astronomers have discovered something that should be impossible, a runaway supermassive black hole, a behemoth that has broken free from its galaxy and is now tearing through the universe, leaving chaos in its wake. This isn't a theory. It's happening right now. But how? How does something that weighs millions, even billions, of times more than our Sun just break free? What does that even mean for the universe? And could this happen to our own galaxy one day? The story of runaway supermassive black holes is one of the strangest mysteries in astrophysics. Black holes, by definition, should be the most stable objects in the universe. They sit at the hearts of galaxies, anchoring them with their immense gravitational pull. They don't just drift away. And yet, we have found evidence that some of them do. This raises questions that no one has definitive answers to, questions that could change our entire understanding of how galaxies form, how gravity works on the largest scales, and whether there are unseen forces at play in the cosmos. To understand what's going on, we first need to talk about how black holes form in the first place. A black hole is born when a massive star collapses under its own gravity. If the star is big enough, at least several times the mass of our Sun, it doesn't just shrink. It collapses so much that it punches a hole in space-time itself, creating a singularity. A point of infinite density. Around this singularity, the black hole forms an event horizon, the point of no return. Anything that crosses it, even light, is gone forever. But these are just stellar black holes, the small ones. Supermassive black holes are a whole different monster. These are millions to billions of times the mass of our Sun, and no one knows exactly how they form. The leading theory is that they start small and grow by devouring gas, dust, stars, and even other black holes over billions of years. Every large galaxy we've ever studied has one of these monsters at its core, including our own Milky Way. But what happens when one of these giants is somehow ejected from its home? This is where things get weird. Black holes don't just drift through space randomly. Their gravity is so strong that moving them takes an unimaginable amount of force. That's why runaway supermassive black holes are such a mystery. Theoretically, the only way to launch one of these behemoths is through an event so violent that it reshapes entire galaxies. And there are only a few things in the universe that could do that. One of them is a galactic collision. When two galaxies collide, their black holes spiral toward each other, drawn by mutual gravity. Over millions of years, they get closer and closer, orbiting each other in a deadly dance until, eventually, they merge into one even larger black hole. But in rare cases, instead of merging smoothly, one of them gets slingshot away at insane speeds. This can happen if a third black hole is involved. It's called the gravitational slingshot effect, and it's the leading explanation for how a supermassive black hole can be ejected from its galaxy. But there's another possibility, one that's even stranger. Some scientists believe that runaway black holes could be the result of something called gravitational recoil. When two black holes merge, they don't just combine their masses. They also release an enormous burst of gravitational waves, ripples in spacetime itself. If this burst is asymmetrical, meaning more energy is released in one direction than the other, the newly merged black hole can get kicked away like a cannonball. And we're not talking about a small push. We're talking about speeds of millions of miles per hour, enough to escape the gravitational pull of its home galaxy entirely. Imagine that, a black hole, one of the most powerful objects in existence, being flung across the universe like a stone skipped across a pond. This brings us to the discovery that shocked the scientific world. In 2023, astronomers spotted something bizarre, a massive black hole, over 20 million times the mass of the Sun, hurtling through space at nearly 4 million miles per hour. It was unlike anything they had ever seen before. Behind it, stretching across 200,000 light-years, was a bright, glowing trail of stars, a cosmic scar left in its wake. This was direct evidence of a runaway supermassive black hole, a nomad wandering the void, leaving destruction and creation in equal measure. The stars in its wake were likely formed by the immense gravitational shockwave it left behind, compressing gas and dust into new suns. This means that a black hole, something that should only destroy, was actually triggering the birth of new stars as it moved. But the question remains, where did it come from? Scientists traced its origin to a galaxy billions of light years away. Something had ejected this monster from its home, but exactly what happened is still up for debate. Some believe it was the result of a triple black hole interaction, with one black hole getting flung away while the other two merged. Others think it was gravitational recoil from a massive black hole collision. Either way, the fact that we found this object at all suggests that there may be many more out there, wandering black holes, invisible until they interact with something. And that raises an even bigger question: could one of these be headed our way? Right now, the answer is no. The chances of a runaway black hole entering our solar system are astronomically small. Space is just too big. Even though there could be countless rogue black holes out there, the distances between objects in space are so vast that we are likely safe. But that doesn't mean we're entirely in the clear. If one were to pass close enough, it wouldn't need to swallow Earth to destroy us. Its gravity alone would be enough to rip our planet apart, distort the orbits of planets, or even eject us from the solar system entirely. And the scary part? We might not even see it coming. Black holes don't emit light. They're invisible unless they interact with something. If a rogue black hole were headed our way, we might only know when it was too late. But beyond the potential dangers, runaway supermassive black holes force us to rethink everything we know about how galaxies evolve. If these monsters can be ejected from their homes, what does that mean for the future of galaxies? Could entire galaxies be left without their central black holes? Could the Milky Way one day lose its own? And what happens to these rogue black holes in the long term? Do they eventually slow down? Do they find new homes? Or do they just wander the universe forever? If runaway supermassive black holes are more common than we thought, the implications for the structure of the universe could be massive. Galaxies are shaped by their central black holes. They control the motion of stars, influence star formation, and even regulate the flow of interstellar gas. Without a central black hole, a galaxy could become unstable, its stars drifting apart over billions of years, leading to a slow but inevitable unraveling. This raises an unsettling question: how many galaxies out there have already lost their black holes? Could there be entire galaxies that appear normal but are, in reality, doomed because they've lost their gravitational anchor? One way scientists are trying to answer this is by searching for more runaway black holes. If we can find more, we might be able to understand how often these ejections happen and what triggers them. But detecting them is tricky. Unlike stars or galaxies, black holes don't emit light. They can only be spotted indirectly, by the effects they have on their surroundings. That's why the discovery of a runaway black hole leaving a trail of stars was so groundbreaking. It gave us a way to look for more. If we find other similar trails of newborn stars stretching across space, we might be able to trace them back to their sources, black holes on the run. There's also the possibility that some of these black holes aren't just aimlessly drifting through space. If they encounter another galaxy, they could get captured by its gravity and become part of an entirely new system. This means that some galaxies might have more than one supermassive black hole, not because they merged with another galaxy, but because they adopted a runaway black hole from somewhere else. This could explain why some galaxies appear to have unusually massive central black holes. Maybe they started with one, but over time, they accumulated others. This brings us to an even wilder possibility. What if runaway supermassive black holes end up clustering together in deep space, forming hidden structures that we can't see? If multiple black holes gather in one region over billions of years, they could merge into something truly monstrous, a black hole bigger than anything we've ever imagined. Some scientists believe that there might be these so-called dark clusters in intergalactic space, massive regions filled with black holes that aren't tied to any galaxy. If these exist, they could be some of the most extreme and mysterious objects in the universe, hiding in the void between galaxies, waiting to be discovered. But let's think even bigger. If black holes can be ejected from galaxies, could entire galaxies themselves be flung into the void? The same gravitational slingshot effect that launches black holes could, in theory, affect entire galaxies in rare circumstances. We already know of rogue planets, planets that have been ejected from their home systems and now drift alone in interstellar space. Could there be rogue galaxies, entire star systems that were flung out of their clusters, doomed to drift through the cosmos forever? And if that's possible, what does it say about the chaotic nature of the universe? The more we learn about runaway black holes, the more questions arise. And one of the biggest mysteries is what happens to these black holes over time. Do they eventually slow down? Theoretically, unless something massive stops them, they should just keep moving through space forever. The universe itself is expanding, meaning there's less and less chance that a rogue black hole will collide with something big enough to stop it. This means that over the course of trillions of years, these black holes could become some of the last surviving objects in the universe, long after all the stars have burned out. This raises another chilling thought. Could runaway black holes be one of the key factors in the ultimate fate of the universe? There are multiple theories about how the universe will end. One of the most well-known is the heat death scenario, where the universe continues expanding until all energy is evenly distributed, leaving nothing but cold, dead remnants of stars and black holes. But if there are countless rogue black holes out there, endlessly drifting, they might continue merging and growing even as everything else fades away. Some scientists speculate that in the far future, the universe could be dominated by supermassive black holes, slowly evaporating over incomprehensibly long time scales due to Hawking radiation. And this is where things get truly mind-bending. If these black holes are the last things left in the universe, what happens when even they disappear? Does the universe just become an empty void? Or is there something beyond that, some unknown physics we haven't yet discovered? Could the energy lost in Hawking radiation somehow trigger the birth of a new universe? Some theories suggest that black holes could be linked to the creation of new universes, with every singularity acting as a kind of cosmic seed for a new reality. If that's true, then runaway black holes aren't just wandering remnants of destruction. They could be the very building blocks of new worlds. If runaway supermassive black holes are the seeds of new universes, then every ejected black hole might hold the potential for an entirely new cosmic landscape hidden beyond our perception. This idea ties into a concept known as black hole cosmology, the hypothesis that our own universe might have been born from the collapse of a black hole in a higher dimensional reality. If this is the case, then the black holes we see roaming through intergalactic space could be the beginnings of brand new universes, each with its own physics, time, and matter, inaccessible to us yet fundamentally connected to our own existence. This raises a strange but compelling question. If runaway black holes can potentially spawn new universes, could we ever find a way to detect these universes? The event horizon of a black hole marks a boundary beyond which no information can escape, at least according to our current understanding of physics. But what if the information isn't lost? Some physicists speculate that information falling into a black hole could be encoded in subtle ways, perhaps even stored as a kind of quantum hologram. If so, could there be some hidden cosmic imprint, some clue left behind, that tells us whether a runaway black hole is, in fact, the seed of a new universe forming beyond the veil of space-time? But before we get too lost in theoretical physics, there's a more immediate mystery. Where exactly are these runaway black holes going? The vastness of space means that even if a black hole is ejected at millions of miles per hour, it would still take billions of years for it to truly leave the vicinity of its home galaxy. But if these objects have been launched throughout cosmic history, some of them could already be deep into intergalactic space, possibly even beyond the observable universe. That means there could be black holes out there that we will never see, moving too far, too fast, for their gravitational effects to ever reach us. And yet, if we think about the scale of the universe, it's likely that some of these rogue black holes are still nearby, relatively speaking. If there's one thing we've learned from astronomy, it's that the universe is full of surprises. Just a few decades ago, the idea of planets existing outside our solar system was purely theoretical. Now, we've confirmed thousands of them. Similarly, if runaway black holes exist, and the evidence suggests they do, then there could be one lurking much closer than we realize. This brings us to a slightly terrifying thought. Could a rogue supermassive black hole ever pass near our own galaxy? The odds are low, but not impossible. The Milky Way is part of a galaxy cluster known as the Local Group, which contains dozens of smaller galaxies. If a black hole was ejected from one of those galaxies millions or billions of years ago, it could theoretically be drifting in our general direction right now. We wouldn't necessarily see it until it got close enough to start distorting the orbits of stars. And by then, we might not have much time to react. Of course, space is mostly empty, and the likelihood of a direct collision is astronomically small. But even a close pass could have dramatic effects. A rogue black hole moving through the outer edges of our galaxy could disrupt the delicate gravitational balance that holds the Milky Way together. It could trigger the formation of new stars, distort the paths of interstellar gas clouds, or even pull some of our own stars along with it, sending them careening into deep space. If that sounds extreme, consider this. Our own galaxy has likely experienced collisions and mergers with other galaxies in the past. The Milky Way is currently on a slow-motion collision course with the Andromeda Galaxy, set to occur in about 4.5 billion years. During that process, it's possible that one or both galaxies' central black holes could be thrown off balance. If the gravitational forces align just right, one of them could be flung away, becoming a rogue black hole itself. So, even if there isn't a runaway black hole heading our way now, one could form right in our cosmic backyard in the distant future. But let's take this idea one step further. If runaway black holes exist, and if they move through intergalactic space at high speeds, could they ever leave detectable marks on the universe itself? Some scientists think the answer is yes. When a black hole moves through space, it drags a gravitational wake behind it, a ripple in spacetime that distorts everything in its path. If we could detect these disturbances, we might be able to map the paths of long-gone runaway black holes, tracing their movements across the cosmos. This could tie into one of the biggest unsolved mysteries in physics: dark matter. Dark matter is an invisible substance that makes up most of the universe's mass, but we don't know what it is. Some researchers have speculated that dark matter could actually be composed of primordial black holes that formed in the early universe before stars even existed. If this is true, then rogue supermassive black holes could be interacting with dark matter in ways we don't yet understand. They could be absorbing it, distorting it, or even using it as a kind of fuel source. And this leads to an even stranger possibility. What if runaway black holes aren't just moving through space randomly, but are actually being attracted to regions of high dark matter density? Some theories suggest that dark matter may form massive, unseen structures in space, structures that could act as gravitational highways for runaway black holes. If these ideas are correct, then rogue black holes might not be aimless wanderers at all. They might be following unseen cosmic highways, tracing paths through the hidden framework of the universe itself. If that's true, then finding more runaway black holes could help us unlock the secrets of dark matter, black hole physics, and perhaps even the fundamental nature of the cosmos. But there's one last, haunting question we haven't considered. Could a runaway black hole ever become a direct threat to Earth? The idea of a black hole drifting through our solar system is the stuff of science fiction horror, but it's not entirely impossible. If a rogue black hole were to come close enough to our solar system, its gravitational pull could disrupt the orbits of planets, potentially sending some of them spiraling into the sun, or flinging them into deep space. The good news is that even if a rogue black hole were nearby, we would likely see its effects long before it got close enough to do serious damage. The bad news? There's a lot of space out there we haven't explored. While we've mapped the visible stars around us, we have no idea how many dark, wandering objects might be lurking just out of sight. Could there be a runaway black hole drifting silently through our cosmic neighborhood, invisible to all but the most sensitive instruments? If so, what would happen if it finally crossed our path? If a runaway black hole were drifting through interstellar space near our solar system, the first signs of its presence would likely be strange gravitational anomalies. Astronomers would notice unexplained shifts in the orbits of distant objects, like the outer planets or Kuiper belt bodies. Over time, these distortions would grow more pronounced, suggesting the approach of a massive, unseen force. But by the time we identified it as a black hole, it might already be too late to do anything about it. The sheer gravitational pull of a rogue supermassive black hole could have devastating effects on our solar system, even from a distance. Unlike smaller stellar mass black holes, which have limited gravitational influence beyond their immediate surroundings, a supermassive black hole carries enough mass to warp the fabric of space itself. If one were to pass within a few light-years of our system, it could perturb the Oort cloud, the vast shell of icy debris that surrounds our solar system, sending a barrage of comets hurtling toward the inner planets. A closer pass would be even worse. The orbits of planets could be stretched and distorted, with some being pulled into elongated, unstable trajectories. If Earth's orbit were disrupted even slightly, the effects could be catastrophic. A small shift in our distance from the Sun could trigger extreme climate changes, throwing the planet into an ice age or causing temperatures to rise beyond habitable levels. If the black hole came even closer, it could rip Earth away from the Sun entirely, sending it drifting into the void of interstellar space, a frozen, lifeless world wandering through eternal darkness. And if, by some nightmarish chance, a runaway black hole were to enter our solar system directly, the results would be apocalyptic. The immense tidal forces would tear apart planets, moons, and even the Sun itself, devouring everything in its path. The gravitational chaos would be unlike anything humanity has ever faced, rendering all attempts at survival futile. But before we panic, it's important to remember that space is incredibly vast. The likelihood of a rogue supermassive black hole passing close enough to disrupt our solar system is extraordinarily low. Still, the fact that these objects exist at all raises deep and unsettling questions. Where did they come from? Where are they going? And could we ever hope to predict their paths with enough accuracy to prevent a future catastrophe? Some scientists believe that advanced gravitational wave detectors could help us track these objects before they get too close. Gravitational waves, ripples in space-time caused by massive cosmic events, could reveal the movements of runaway black holes long before they pose a direct threat. But this technology is still in its infancy. By the time we develop the ability to detect these objects with precision, it may already be too late to do anything about them. There's also the question of whether these runaway black holes could be harnessed for scientific or even practical purposes. Some physicists have speculated that black holes could be used as energy sources, with their immense gravitational forces allowing for the extraction of unimaginable amounts of power. If humanity ever reaches a level of technological advancement where we can safely study and manipulate black holes, runaway supermassive black holes might become targets of scientific exploration rather than objects of fear. But this is purely theoretical. For now, runaway black holes remain one of the greatest cosmic mysteries, hidden, elusive, and capable of rewriting everything we think we know about the universe. They are silent wanderers, moving through the darkness, carrying secrets of galaxies long past. They may hold answers to the biggest questions in physics, or they may be harbingers of destruction, waiting for the moment when they drift too close to an unsuspecting world. Perhaps, somewhere out there, a rogue black hole is already on its way toward us, its approach hidden by the vast distances of intergalactic space. Perhaps, in the distant future, humanity will witness the arrival of one of these cosmic titans, forcing us to confront the reality of our place in the universe. Or perhaps, for now, we are simply lucky, fortunate to exist in a time and place where these celestial wanderers remain far beyond our reach. One thing is certain, the universe is full of mysteries, and runaway black holes are among the most chilling of them all. They remind us that the cosmos is not a static, predictable place. It is a realm of constant motion, where even the mightiest objects, galaxies, stars, and supermassive black holes, can be cast adrift, lost in the endless expanse of space. And so, we are left with more questions than answers. How many of these runaway black holes are out there, moving unseen through the void? Could one be heading toward us even now? And if so, would we ever know before it was too late? The mystery remains unsolved, lurking in the vast unknown, waiting for the moment when science finally catches up to the cosmic forces that shape our universe. Runaway supermassive black holes are a terrifying yet fascinating reality of the universe. They are invisible wanderers, moving through intergalactic space with no fixed path, ejected from their home galaxies by forces so immense that even objects as unimaginably massive as these can be sent drifting across the cosmos. Unlike regular black holes, which typically remain anchored within galaxies, these monsters have broken free, cast out by cataclysmic gravitational events. The question is, how did they become rogue entities? What happens when they collide with other cosmic structures? And could one ever drift into our galactic neighborhood? The most widely accepted explanation for the creation of a runaway supermassive black hole involves galactic collisions and mergers. When two galaxies collide, their central supermassive black holes spiral toward each other, locked in a gravitational dance that can last for millions of years. Eventually, these black holes merge into a single, even larger entity. However, this merger is not always a perfectly symmetrical process. If the two black holes have different masses or are spinning at different rates, the energy released in the merger can be unevenly distributed. This imbalance can create a tremendous recoil effect, known as a gravitational wave kick, which can send the newly formed black hole hurtling away at speeds of thousands of kilometers per second. This ejection mechanism is based on Einstein's general theory of relativity, which predicts that merging black holes generate powerful gravitational waves, ripples in spacetime that carry energy away from the system. If these waves are emitted asymmetrically, the merged black hole experiences a recoil, much like a cannon recoiling after firing a projectile. If this recoil velocity exceeds the escape velocity of the galaxy, the black hole will be flung outward, never to return. It becomes a runaway, a rogue entity, doomed to drift through intergalactic space, tearing through cosmic dust clouds, and potentially even consuming entire stars along its journey. Once a supermassive black hole is ejected, it doesn't simply fade away. It continues to behave as any other black hole would, distorting spacetime, pulling in matter, and growing larger as it consumes whatever crosses its event horizon. Unlike a stationary black hole at the center of a galaxy, however, a runaway supermassive black hole moves unpredictably. If it carries a cloud of matter or gas from its former host galaxy, it may continue to shine brightly in X-rays and radio waves, allowing astronomers to track its movement. Some theorists suggest that we have already detected such objects, strange, bright sources of energy that do not seem to be associated with any galaxy. These could be runaway black holes speeding through the universe, still trailing the remnants of their past. What happens when a runaway supermassive black hole crosses paths with another galaxy? If it collides directly with a new galactic core, the results could be spectacular. The invading black hole would begin devouring material from the host galaxy, forming a bright accretion disk as gas and dust spiral into its depths. If it encounters another supermassive black hole in its new environment, the two could form a new binary system, repeating the cycle that initially ejected it from its original home. But in many cases, a rogue black hole may simply pass through a galaxy without ever being detected, its gravity disturbing star systems slightly but not causing enough chaos to reveal its presence. Perhaps the most unsettling possibility is that some of these objects may be headed in our direction. While the chances of a runaway supermassive black hole passing close to the Milky Way are incredibly small, they are not zero. Space is vast, but the universe is dynamic, with galaxies moving and interacting over cosmic timescales. If a rogue black hole were to approach our galaxy, it could eventually be captured by the Milky Way's gravity and begin interacting with its stars, pulling them into chaotic orbits or even consuming them outright. Over millions of years, such a black hole could carve a path of destruction, tearing apart entire star clusters as it makes its way toward the galactic core. Even if a runaway supermassive black hole never directly enters the Milky Way, its effects could still be felt across intergalactic distances. The gravitational waves emitted by such objects as they interact with the cosmic environment could distort spacetime in ways we have yet to fully understand. Future observatories, designed to detect these waves with greater precision, may be able to map the locations and trajectories of these rogue behemoths, helping us predict their movements. If we ever detect one heading in our direction, would we be able to do anything about it? Could we develop some means of deflecting or avoiding such a cosmic catastrophe? Or would we simply have to accept our fate as the latest victims of the universe's unrelenting chaos? The study of runaway supermassive black holes is still in its infancy. Because they are incredibly difficult to detect, much of what we know is based on theoretical models and indirect evidence. But as our technology improves, we may soon uncover more of these wandering giants, lurking in the darkness between galaxies. Each discovery will bring new questions, new fears, and perhaps even new opportunities for understanding the fundamental forces that shape our universe. The thought of a supermassive black hole moving freely through space is enough to make anyone uneasy. These objects defy the very idea of stability, proving that even the most massive structures in the universe can be displaced, thrown out of their homes, and set adrift in the void. They remind us that the cosmos is not a calm, orderly place, but a realm of constant motion and upheaval. And somewhere, right now, one of these monsters may be drifting toward an unknown future, its path unpredictable, its hunger endless, its story still waiting to be told. If a runaway supermassive black hole were truly out there, hurtling through intergalactic space on an unpredictable course, how would we detect it? Unlike regular black holes nestled in galactic centers, these rogue behemoths don't have the benefit of a constant supply of gas and dust to feed on. That makes them far less visible than their stationary counterparts. But they aren't completely invisible. If a runaway black hole carries some of its former galaxy's material along with it, it might still have an active accretion disk, a swirling, superheated mass of gas that emits intense radiation. This could make it detectable in X-rays, radio waves, or even visible light if it were close enough. Another clue would be the gravitational effect such a black hole has on its surroundings. Though a supermassive black hole is a relatively small object in cosmic terms, only a few times larger than our Sun in diameter, its gravitational pull is extreme. If it passed through a region with stars or gas clouds, it could bend the light of distant objects behind it, creating a phenomenon known as gravitational lensing. This warping of spacetime could reveal the presence of an otherwise hidden black hole. Scientists searching for rogue black holes have looked for such distortions, though proving that any single detection is a runaway black hole rather than a more conventional object remains a challenge. And then there's the possibility of direct interaction. If a runaway supermassive black hole were to collide with another galaxy, the effects would be dramatic. As it entered, it would begin pulling on the stars and gas, creating elongated, chaotic orbits as it exerted its enormous gravitational influence. If it came close enough to another supermassive black hole already at the galaxy's core, the two could form a binary system, spiraling toward each other over millions of years until eventually merging in an event so violent that it would send ripples through the fabric of spacetime itself. Such an event would produce gravitational waves detectable by instruments like LIGO and Virgo, which are designed to measure these cosmic tremors. But what if one of these rogue giants was heading toward the Milky Way? Given that our galaxy is constantly moving through space, interacting with its cosmic neighbors, it is not beyond the realm of possibility that a supermassive black hole, displaced by some distant collision, could eventually find itself drawn into our galactic neighborhood. If it were still far enough away, we might have time to detect it before it became a direct threat. The first signs might be subtle, unexplained changes in the orbits of objects at the edges of the Milky Way, where the gravitational influence of such a massive object would first be felt. Over time, as it drew closer, its effects would become more pronounced. In the worst-case scenario, a rogue supermassive black hole could approach the Milky Way at just the right angle and speed to become gravitationally captured. It wouldn't immediately plunge into the galactic center. Instead, it would settle into a wildly elliptical orbit, swinging through the galaxy like a wrecking ball on a cosmic scale. Each pass would distort the orbits of stars, potentially ejecting entire solar systems into deep space or sending them careening into the galactic core. Over millions of years, the Milky Way itself could become unrecognizable, reshaped by the presence of this unwelcome intruder. Even without a direct collision, the presence of a rogue black hole could have devastating effects on its surroundings. The gravitational disturbances it causes could trigger star formation in unexpected places or disrupt existing planetary systems. If it passed too close to a dense molecular cloud, it could spark the birth of new stars, altering the evolution of entire regions of the galaxy. Conversely, if it moved through an already developed star cluster, it could tear the cluster apart, scattering its stars into interstellar space. For planets unlucky enough to be in its path, the results would be catastrophic. If a runaway black hole approached a solar system, it could throw planets out of their orbits, either sending them crashing into their parent star or flinging them into the void, turning them into rogue planets drifting in darkness. Even without direct collision, the gravitational influence of such a massive object would cause extreme tidal forces, which could rip apart moons, create massive tectonic upheavals, and trigger planetary-scale disasters. And then there's the possibility, remote but terrifying, that a runaway supermassive black hole could directly enter our solar system. If one were to approach within a few light years, its gravitational pull would begin to affect the orbits of planets, stretching them into elongated ellipses that could result in extreme climate shifts. Earth, for example, might find itself alternately freezing and overheating as its distance from the Sun fluctuated unpredictably. If the black hole came even closer, it could pull Earth completely out of its orbit, sending it drifting into the cold abyss of interstellar space. The most extreme scenario would be a direct collision. If a runaway supermassive black hole were to pass close enough to the Sun, it could siphon away solar material, feeding on our star until it was completely consumed. The entire solar system would collapse into chaos, as the planets were either devoured or cast off into space. It's a fate so incomprehensible that it almost seems like science fiction, but the laws of physics say it is theoretically possible. Thankfully, the odds of such an event happening within our lifetime are vanishingly small. The universe is vast, and while runaway supermassive black holes do exist, space is so enormous that direct collisions are incredibly rare. Even if a rogue black hole were headed in our direction, it would likely take millions or even billions of years before it reached us. But the fact that such a possibility exists at all is enough to make us rethink everything we know about the stability of the cosmos. Runaway black holes are a reminder that the universe is not a place of permanence. Everything, galaxies, stars, even supermassive black holes themselves, is in motion. Nothing stays in one place forever. The forces of gravity and energy are constantly reshaping the cosmos in ways we are only beginning to understand. And somewhere out there, drifting in the darkness, a runaway supermassive black hole continues its silent journey through the void, an unstoppable force, heading toward an unknown fate. If a runaway supermassive black hole is truly out there, drifting through intergalactic space, it challenges everything we assume about the order of the cosmos. We tend to think of galaxies as stable structures, each with a well-anchored core, a supermassive black hole sitting peacefully at its center, slowly consuming matter over billions of years. But the existence of these rogue black holes tells us that the universe is more chaotic than we imagine. Galaxies collide, black holes get ejected, and entire celestial structures are torn apart by forces so immense they are beyond human comprehension. One of the most mind-boggling things about runaway supermassive black holes is just how fast they move. When a black hole is ejected from a galaxy, it doesn't just float away at a slow drift. It can be propelled at speeds of millions of miles per hour. Some estimates suggest that the fastest ones might be traveling at nearly 5,000 miles per second, far surpassing the speed needed to escape a galaxy's gravitational pull. At that velocity, a runaway black hole could travel from Earth to the Moon in less than a minute. It could cross the entire Milky Way in a few million years, a blink of an eye in cosmic terms. But what exactly happens to these black holes once they leave their home galaxies? Most of space is empty, meaning that a runaway supermassive black hole could spend billions of years moving through the void without encountering anything significant. However, space is not completely empty. There are rogue stars, interstellar gas clouds, and even entire dwarf galaxies drifting through the cosmos. If a black hole passed through one of these objects, its gravity would disrupt everything in its path. Imagine a small, quiet galaxy drifting in space, its stars following predictable orbits, its clouds of gas and dust slowly forming new solar systems. Then, suddenly an invisible force arrives, a runaway black hole, moving at an incredible speed, completely undetectable until it's too late. At first, the effects might be subtle. Stars on the galaxy's outskirts begin shifting in their orbits, their paths warping under the influence of an unseen gravitational force. Then, as the black hole moves deeper into the galaxy, its pull becomes stronger, flinging some stars into intergalactic space while drawing others toward its event horizon. Over thousands or even millions of years, the entire structure of the galaxy could be torn apart, transformed into a chaotic, elongated mess of stars and gas. The most fascinating question is whether a runaway supermassive black hole could ever gain enough mass to become the dominant force in a new galaxy. If a rogue black hole drifts through space for billions of years, devouring whatever it encounters, could it eventually settle into a new home, replacing a galaxy's original central black hole? It's possible. A runaway black hole that entered a galaxy's core and merged with an existing supermassive black hole would create an even more massive singularity. This process could happen over and over again across cosmic time, leading to the formation of black holes so unimaginably huge that they defy current astrophysical models. This raises another mind-blowing possibility. What if some of the largest black holes we see today, the ones with masses billions of times greater than our Sun, are actually the remnants of ancient runaway black holes that have been colliding and merging for eons? What if the biggest black holes didn't form in a single galaxy but are the result of multiple ejections, collisions, and mergers stretching across cosmic history? One way scientists search for runaway black holes is by looking at the strange, lopsided shapes of galaxies. When a supermassive black hole is kicked out of a galaxy, it doesn't just leave quietly. The gravitational force it exerted on the surrounding stars is suddenly gone, and the galaxy can lose its symmetry. Instead of a well-formed spiral or elliptical shape, the galaxy might look distorted, as if it has been stretched or pulled in one direction. Some astronomers believe that certain irregular galaxies might be the result of past black hole ejections, where a once central black hole was launched into space, leaving behind a misshapen, chaotic stellar structure. Another potential sign of a runaway black hole is the presence of strange, unexplained light sources in deep space. When a black hole moves through a dense gas cloud, the material around it can become superheated, glowing brightly in X-rays and radio waves. These glowing regions, known as hypervelocity light sources, might be evidence of rogue black holes making their way through the universe. The idea of rogue black holes also raises serious questions about the fate of galaxies. If black holes can be ejected, then does that mean that some galaxies are left without a central black hole at all? If so, how does that affect star formation and galactic structure? Current models suggest that supermassive black holes play a crucial role in regulating the growth of galaxies by controlling the flow of matter and energy. If a galaxy loses its central black hole, does it continue to evolve normally, or does it slowly fall apart over billions of years? Could there be galaxies out there wandering through space, broken and dying, because they lost their black holes long ago? And then there's the question of whether our own Milky Way has ever ejected a black hole. If supermassive black holes can be kicked out of galaxies, has it ever happened here? Some astrophysicists believe it's possible that our galaxy once had multiple supermassive black holes in its core, the result of past mergers with smaller galaxies. If that's the case, then perhaps one or more of those black holes were ejected millions or billions of years ago, now drifting somewhere in the vastness of intergalactic space. But what if it happened again? Could the Milky Way's central black hole, Sagittarius A*, ever be ejected? Theoretically, if our galaxy merged with another large galaxy and their central black holes formed a binary system, a powerful gravitational interaction could send one of them flying into deep space. That would mean the Milky Way would be left without its central anchor, changing the structure of our galaxy forever. All of this makes runaway supermassive black holes one of the most unpredictable and terrifying forces in the universe. Unlike other cosmic threats, such as asteroid impacts or supernova explosions, there would be almost no warning if one were approaching. Since black holes don't emit light, a rogue black hole could be moving toward us right now, undetectable until it was close enough for its gravitational effects to become apparent. By the time we noticed, it might already be too late. But while the idea of a rogue black hole heading for Earth is terrifying, The sheer scale of the universe makes it highly unlikely. Space is unimaginably vast, and even though runaway black holes are out there, the chances of one coming anywhere near our solar system are incredibly small. That said, the more we learn about these wandering giants, the better we understand the unpredictable, ever-changing nature of the cosmos. Runaway supermassive black holes are not just theoretical oddities. They are proof that the universe is in constant motion, shaped by forces beyond our control. They remind us that nothing is fixed, nothing is permanent, and even the most massive structures in the cosmos can be cast adrift, doomed to wander the void forever. Somewhere out there, right now, a supermassive black hole could be moving silently through space, unseen and unstoppable, carrying the remnants of a shattered galaxy with it. It is a force beyond comprehension, a reminder that even in the deepest darkness, the universe is alive with motion and mystery. If a runaway supermassive black hole is drifting through the void, what happens when it finally encounters another massive structure? Would it simply pass by unnoticed, or would its presence unleash an entirely new chain of cosmic destruction? One of the most intriguing possibilities is that a rogue black hole might eventually collide with another supermassive black hole, triggering one of the most violent and energetic events in the universe: a black hole merger. When two black holes collide, the amount of energy released is almost unimaginable. The fabric of space-time itself ripples, creating gravitational waves that spread outward at the speed of light. These waves carry so much energy that they can travel billions of light years across the cosmos, detectable even here on Earth with instruments like LIGO and Virgo. But if one of the black holes in the merger was a runaway, moving at incredible speeds, the resulting event could be even more dramatic than anything we've observed before. Scientists theorize that when a high-speed runaway black hole collides with another supermassive black hole, the force of the impact could create a burst of energy greater than the combined output of every star in an entire galaxy. This explosion of gravitational waves would be so powerful that it could momentarily distort space-time itself, creating ripples that might even be detectable in distant galaxies. But what if a runaway black hole doesn't collide with another black hole? What if instead, it drifts into a dense star cluster, a young galaxy, or even a nebula filled with gas and dust? The consequences could be just as catastrophic. A runaway black hole passing through a dense region of space would begin pulling in matter at an accelerated rate, forming an accretion disk around it. This disk of superheated gas would glow brightly in X-rays and radio waves, making the black hole suddenly visible to astronomers. If we ever detect a bright, unexpected X-ray source moving through the cosmos, it might not be a new star or a distant galaxy. It might be a supermassive black hole on the move. One of the strangest and most terrifying ideas is that a runaway supermassive black hole could eventually form its own system of orbiting objects. If a black hole were ejected from a galaxy with enough surrounding debris, such as stars, gas clouds, and even planets, some of that material might remain gravitationally bound to it. In this scenario, the runaway black hole wouldn't just be traveling alone. It could be carrying an entire mini-galaxy with it, a rogue cluster of stars moving together through the universe, dragged along by the unstoppable force of the black hole at its core. This concept leads to an even more mind-bending possibility. What if a runaway black hole was carrying habitable planets along with it? If a black hole were ejected from a galaxy while still surrounded by orbiting stars and planets, some of those worlds might remain in stable orbits, even as they were flung into deep space. In this case, there could be entire solar systems adrift in the void, moving between galaxies, cut off from the rest of the cosmos. If life existed on any of those planets, it would experience a universe completely unlike our own, one without a night sky full of stars, one where the only visible celestial object was the eerie glow of the accretion disk around their black hole. Could civilizations exist on such planets? It's an idea that pushes the limits of imagination, but in theory, it's not impossible. Life on a rogue planet orbiting a runaway black hole would have to evolve under extreme conditions. Without the warmth of a nearby star, such a world would likely be frozen, its only source of heat coming from geothermal activity deep beneath its surface. But if life found a way to survive, it would exist in complete isolation, unaware of the vast galaxies beyond the black hole's pull. To any beings living on such a planet, the universe might seem like a cold, empty place, with no knowledge of the countless stars, planets, and civilizations that exist beyond their dark, drifting world. Astronomers continue searching for evidence of runaway supermassive black holes, but detecting them is no easy task. Since black holes do not emit light, they can only be found by their gravitational effects on nearby objects. This means that if a rogue black hole is traveling through empty space, completely detached from any surrounding matter, it might be completely invisible to us. We could only infer its existence by detecting gravitational waves from its past interactions or by noticing unexplained distortions in the motion of distant galaxies. However, some scientists believe we may have already found indirect evidence of runaway black holes. Observations of certain galaxies have revealed strange, off-center bright spots, areas of intense radiation that do not align with the expected position of the galaxy's core. Some astronomers theorize that these bright spots might be the remnants of black holes that were ejected long ago, now slowly moving through space, still consuming matter as they drift away from their former homes. Another potential sign of runaway black holes is the presence of unusually large voids in space. If a black hole was ejected from a galaxy millions or billions of years ago, it would have left a gravitational imprint on its surroundings. Over time, this could create a region of space where stars and gas are noticeably absent, as if something massive had once passed through, pulling everything along with it. Some of the largest cosmic voids observed by astronomers could be the result of past black hole ejections, leaving behind vast, empty regions of space that may never be filled again. The search for runaway black holes is also connected to another major mystery: the origins of the most massive black holes in the universe. Some of the largest black holes we have ever detected are so enormous that they seem impossible to explain using current models of galaxy formation. These behemoths, with masses billions of times greater than the Sun, may have formed through repeated mergers of runaway black holes, slowly accumulating mass over billions of years as they move through space, devouring everything in their path. This raises an unsettling question: could there be a single black hole so massive that it dominates the entire universe? If runaway black holes have been merging and growing for billions of years, could one of them have reached a size beyond anything we can imagine? Some scientists speculate that a cosmic black hole of this magnitude could theoretically exist, a singularity so enormous that it bends the very structure of the universe around it. If such a black hole were moving through space, it could be consuming galaxies as it travels, slowly erasing entire regions of the cosmos from existence. The more we learn about runaway supermassive black holes, the more they force us to rethink what we know about the universe. They remind us that the cosmos is not a calm, orderly place but a dynamic, chaotic battleground where even the most massive objects can be flung into the void, forever lost in the darkness. Somewhere out there, beyond the edge of what we can see, a rogue black hole might be moving right now, carving a path through the cosmos, carrying with it the remnants of a forgotten galaxy, drifting endlessly through the void. If a runaway supermassive black hole is truly out there, drifting through the cosmos, then the implications are staggering. It would mean that the universe is even more chaotic than we ever imagined, and that no galaxy, no matter how stable it appears, is truly safe from these cosmic juggernauts. A black hole moving at millions of miles per hour would be almost unstoppable, an invisible force plowing through everything in its path. But what happens if one of these rogue behemoths were to make its way toward our own galaxy? Could the Milky Way be at risk from a runaway supermassive black hole? To answer this, we have to consider two things: the probability of such an event and the consequences if it actually happened. First, the probability. Space is unimaginably vast, and galaxies are separated by enormous distances. Even if a black hole is ejected from a galaxy, the chances of it randomly intersecting with another galaxy are relatively low. However, given the vast timescales of the universe, low probability events eventually become inevitable. Over billions of years, a runaway black hole could eventually find itself on a collision course with another galaxy, including our own. If such a black hole were heading toward the Milky Way, we might not even see it coming. Unlike stars, which shine brightly and can be detected from billions of light years away, black holes are invisible unless they are actively consuming matter. A runaway black hole that isn't currently feeding might only be detectable by the way it distorts the light of background stars or by its gravitational influence on nearby objects. In other words, it could be moving silently through the void, undetectable until it was too late. But let's say, hypothetically, that a runaway supermassive black hole did enter the Milky Way. What would happen? The consequences would depend on its trajectory and speed. If it passed through a less densely populated region of our galaxy, it might not have a dramatic impact right away. But if it moved through a region with a high concentration of stars, things would get catastrophic very quickly. Stars would be ripped from their orbits, entire planetary systems would be thrown into chaos, and massive clouds of gas would be sucked into the black hole's event horizon, triggering violent outbursts of radiation. Over time, a runaway black hole moving through the Milky Way could even begin to disrupt the gravitational balance of our galaxy as a whole. The Milky Way, like most galaxies, is held together by the delicate gravitational dance of billions of stars orbiting around the supermassive black hole at its center, Sagittarius A star. If another supermassive black hole were to intrude upon this system, it could destabilize everything. Stars that had remained in stable orbits for billions of years could suddenly be thrown outward, ejected from the galaxy entirely. Others could be drawn inward toward one of the black holes, triggering a cataclysmic collision. And what about Earth? Would we be in danger? The answer depends entirely on distance. If a runaway black hole were to pass anywhere near our solar system, the gravitational effects alone would be devastating. Planets could be nudged out of their orbits, altering their climates and making life impossible. Even if Earth weren't directly swallowed by the black hole, the mere disturbance of our orbit around the Sun could lead to catastrophic consequences. Our planet could be flung into deep space, where it would freeze into a lifeless ice world, or it could spiral inward toward the Sun, where it would be incinerated. But even if a runaway black hole never comes close to our solar system, its mere presence in the Milky Way would be cause for concern. As it moves, it would create gravitational waves, ripples in space-time that spread outward like waves on a pond. These waves could subtly alter the orbits of objects throughout the galaxy, setting off chain reactions that might not become noticeable for millions of years. In essence, a single rogue black hole could reshape the entire future of the Milky Way, changing the destiny of stars and planets on a cosmic timescale. What's truly terrifying is that we might never see it coming. A runaway black hole, especially one that isn't actively feeding, could be nearly impossible to detect with our current technology. By the time we noticed its effects, stars moving in unexpected ways, distant galaxies showing strange distortions, it might already be too late. The idea that such an object could be moving toward us right now, completely undetectable, is a humbling reminder of how much we still don't know about the universe. But let's take this thought experiment one step further. What if a runaway black hole has already passed through our galaxy in the distant past? Could there be evidence hiding in the structure of the Milky Way itself? Some scientists have speculated that certain unexplained gaps in the distribution of stars, or the peculiar motions of certain stellar groups, could hint at the past passage of an unseen massive object. If a black hole once moved through our galaxy, it might have left scars, distortions in the gravitational field, unexplained voids where stars should be, or even faint gravitational wave echoes that we might one day detect with more advanced observatories. And then there's the ultimate question: could the presence of runaway black holes be one of the missing pieces in our understanding of dark matter? Dark matter is one of the greatest mysteries in modern physics, an invisible substance that makes up most of the mass in the universe, yet doesn't interact with light in any way. Some researchers have proposed that at least some of what we call dark matter might actually be a population of black holes drifting through the cosmos, unseen but exerting their gravitational influence on galaxies. If runaway supermassive black holes exist in large numbers, they could be contributing to this hidden mass, shaping the evolution of galaxies without us even realizing it. So where does that leave us? Right now, we are still in the early stages of understanding runaway supermassive black holes. We have only just begun to identify potential candidates, objects that appear to be moving at extreme speeds, defying our expectations of how supermassive black holes should behave. Future telescopes, especially those designed to detect gravitational waves, may give us more clues, allowing us to pinpoint the locations of these cosmic wanderers. But for now, they remain one of the greatest unknowns in astrophysics, silent, invisible, and potentially everywhere. Perhaps the most unsettling thought is this: somewhere, right now, a runaway black hole could be passing through the void, unnoticed, untraceable, moving toward an unknown destination. It could have already consumed entire star systems, erased the histories of long-forgotten civilizations, and left trails of destruction that we have yet to discover. And if one of these cosmic titans is ever on a direct path toward us, we may never even know until it is far too late. If a runaway supermassive black hole were heading toward us, what could we do about it? The answer, quite simply, is nothing. Unlike an asteroid or a rogue star, which we might theoretically deflect or avoid, a black hole is something we have absolutely no power over. Even if we somehow detected it early, no amount of technological advancement could stop it. The gravitational pull of a supermassive black hole is so overwhelming that even light itself cannot escape it. And if one were barreling through the cosmos, it wouldn't just destroy individual planets or stars. It would warp space-time itself, creating chaos on a scale we can barely comprehend. To make matters worse, detecting one in advance is far from guaranteed. Black holes, by their very nature, do not emit light. Unless they are actively consuming matter, they remain nearly invisible to even our most advanced telescopes. The only way we can detect them is through their gravitational effects, how they distort nearby stars, how they bend light, how they send ripples through space-time. But by the time we notice those effects, the black hole may already be dangerously close. And what would it feel like if such a black hole passed near our solar system? The first signs might be subtle. The orbits of distant objects in the Oort cloud, the icy region at the edge of our solar system, might begin to shift in ways we couldn't immediately explain. Comets that had remained undisturbed for billions of years might suddenly start hurtling toward the inner solar system. Slowly, our sun's gravitational balance would be disturbed, not dramatically at first, but enough that planetary orbits might start to shift, tiny changes that would eventually add up to disaster. Then, if the black hole moved closer, the disruption would become more severe. Earth's orbit might stretch or shrink, altering our seasons in unpredictable ways. A shift of just a few million miles could mean the difference between a stable climate and a planet either too hot or too cold to sustain life. If the black hole were on a direct collision course, we wouldn't even get the chance to worry about climate change. Our planet would be pulled toward the event horizon, stretched into oblivion by tidal forces long before we ever reach the singularity. But let's step back from this nightmare scenario for a moment. Could a runaway supermassive black hole explain any cosmic phenomena we've already observed? Some scientists believe that they might account for the unexplained high-speed motions of certain stars. We've detected stars moving at incredible velocities, sometimes even being ejected from the Milky Way entirely. Traditionally, these hypervelocity stars were thought to be slingshot by interactions with Sagittarius A*, the supermassive black hole at our galaxy's center. But what if, instead, they were influenced by an unseen, wandering black hole, one that had long since left the galaxy, but not before disturbing everything in its path? There's also the question of unusual voids in space, vast, empty regions where few stars exist. Could a runaway black hole have carved out one of these voids, consuming everything in its path before drifting onward? Some astronomers have speculated that these empty regions might be scars left by massive black holes that once passed through, leaving nothing behind but a gravitational shadow. And then there's an even wilder idea, one that stretches the limits of our understanding. Could runaway black holes be traveling between galaxies? Normally, galaxies are thought to be relatively stable, bound together by dark matter and their central black holes. But if a black hole can be ejected from one galaxy, then it's possible that some are now traveling freely in the vast voids between galaxies. If that's true, then the universe may be littered with unseen, intergalactic wanderers, black holes drifting in the darkness, never staying in one place, forever moving towards some unknown destination. This possibility raises an even more terrifying question. Could our galaxy one day lose its own central black hole? If Sagittarius A** were somehow ejected, perhaps by a collision with another supermassive black hole, what would happen to the Milky Way? The immediate effects might not be as dramatic as one might think. The stars in our galaxy wouldn't suddenly fly apart overnight, as their orbits are still governed by the combined gravity of all the matter in the galaxy. However, over millions or even billions of years, the absence of a central black hole could lead to the slow unraveling of the Milky Way as a whole. Without Sagittarius A** anchoring everything in place, the orbits of stars would gradually drift, and the galaxy could eventually lose its shape. It might stretch out, disperse, or even break apart entirely, its stars slowly drifting into intergalactic space. In a sense, the loss of a supermassive black hole could spell the beginning of the end for a galaxy. And what if this has already happened elsewhere? Could there be ancient, ghostly remnants of galaxies that lost their black holes long ago, now nothing more than scattered stars, no longer bound together, slowly fading into the void? If we could identify such dead galaxies, it might provide further evidence that runaway black holes are more common than we ever realized. But even if we assume that runaway black holes exist, we still have a lot to learn about them. We don't yet know how common they are, how many might be lurking in the universe, or whether they truly pose a threat to galaxies like ours. Future telescopes, like the upcoming space-based gravitational wave detectors, might finally give us the ability to track them, detecting their movements as they disturb the fabric of space-time itself. One thing is certain: if runaway supermassive black holes are real, then they represent one of the greatest unknowns in astrophysics. They are silent, invisible, and potentially everywhere. They might be shaping galaxies in ways we have yet to understand. They might be responsible for unexplained cosmic events. And perhaps most unsettling of all, they might already be on their way toward us, hidden in the darkness, creeping closer with each passing moment. If a runaway supermassive black hole were heading toward us, would we even see it coming? The unsettling reality is that we might not. Unlike stars, which shine brightly, or even planets, which reflect light, black holes are almost completely invisible. They do not emit light on their own, and unless they are actively consuming matter, they leave very little trace of their presence. The only way we might detect one early is through the gravitational effects it has on surrounding celestial objects. But even that isn't guaranteed, especially if the black hole is moving through the vast, mostly empty regions of intergalactic space, where there is little matter to interact with. This means that a runaway supermassive black hole could be heading toward us right now, and we would have no way of knowing. The first real signs of its approach might not come until it was close enough to begin subtly affecting the orbits of distant objects in our solar system. Imagine a time in the future when astronomers start noticing strange perturbations in the orbits of the outer planets. Maybe Neptune and Uranus begin drifting slightly out of their expected paths. At first, it might be dismissed as observational error, but as more data comes in, a horrifying realization begins to dawn: something massive, something with an enormous gravitational pull, is approaching. And once it gets close enough, things would start to change rapidly. The delicate gravitational balance that holds our solar system together would begin to unravel. The orbits of planets would become increasingly unstable. Tidal forces would grow stronger, causing devastating effects on Earth. If the black hole passed close enough, it might not even need to directly collide with anything to destroy it. Its gravity alone could stretch and distort planets beyond recognition. And if Earth got caught in its influence, we wouldn't just fall into it instantly. Instead, we would be stretched and warped by its gravity, experiencing what physicists call spaghettification, as the difference in gravitational pull between our planet's near side and far side would be extreme. But let's take a step back. What if a runaway supermassive black hole passed near our solar system but didn't pull us in? Would we survive? The answer is complicated. Even if Earth avoided direct destruction, the Sun itself could be affected. If the black hole were to interact with our star's gravity, it could distort the Sun's orbit within the Milky Way or even pull it out of place entirely. If that happened, the habitable zone of our solar system, the delicate region where Earth can sustain life, could shift drastically. Even a small shift in our sun's position could lead to catastrophic climate changes, plunging Earth into an ice age or heating it to unlivable extremes. And if the black hole came even closer? It might begin stripping material from the sun itself, feeding on the very energy that sustains life on Earth. The sun could enter a state of chaos, its outer layers being pulled away, disrupting its natural fusion processes. In the worst-case scenario, the sun could be completely consumed, leaving Earth drifting in the darkness of space, cut off from its only source of heat and light. If that happened, life on our planet would not last long. The oceans would freeze, the atmosphere would collapse, and within a matter of weeks, Earth would become a frozen wasteland. Even if a black hole passed by at a greater distance, without directly affecting our sun, it could still send devastating shockwaves through the Milky Way. It could disturb the orbits of countless stars, triggering massive chain reactions. Stars that were once in stable orbits might be flung out of the galaxy entirely. Entire solar systems could be ejected into intergalactic space, doomed to drift forever in the cold emptiness between galaxies. This raises another terrifying possibility. Has this already happened? Could runaway supermassive black holes be responsible for some of the unexplained cosmic phenomena we've observed? Scientists have long speculated about the existence of rogue planets that do not orbit any star, instead drifting freely through the darkness of space. Where did these planets come from? Could some of them have been ejected from their home solar systems by a passing black hole? There's also the question of intergalactic stars that are not bound to any galaxy but instead move freely through space. Traditional theories suggest these stars may have been thrown out by interactions with other stars or by gravitational slingshot effects near galaxy cores. But what if some of them were actually displaced by a runaway supermassive black hole? Could we be seeing the aftermath of a black hole that once tore through a galaxy, flinging stars and planets in all directions before vanishing into the void? And then there are cosmic voids, vast, empty regions of space where very few galaxies exist. These voids are some of the largest known structures in the universe, spanning hundreds of millions of light-years. Scientists have proposed many theories to explain them, from dark energy effects to the large-scale distribution of matter after the Big Bang. But one radical idea suggests that runaway black holes might play a role. What if these voids are not just empty space, but scars left behind by black holes that have consumed everything in their path? Could these voids be the remnants of ancient galactic destruction? If true, this would mean that runaway black holes are not just a curiosity. They are an active force shaping the structure of the universe. They may be carving out the large-scale patterns of galaxies, influencing the fate of entire star systems, and potentially threatening the stability of everything we know. And if we accept that runaway black holes are real, we have to ask, where are they now? Are there any near our galaxy? Are they more common than we think? Could one already be heading toward us, hidden just beyond the reach of our telescopes? The more we study black holes, the more we realize how little we understand about them. They are the most powerful objects in the universe, and yet, they remain one of the greatest mysteries in astrophysics. One day, we might develop the technology to detect and track these cosmic wanderers before they come too close. But for now, we can only watch the stars and hope that somewhere, deep in the darkness of space, a supermassive black hole isn't silently making its way toward us. If a runaway supermassive black hole were headed in our direction, how much time would we have? The answer depends on its speed, distance, and trajectory. Most of the known supermassive black holes travel at incredible speeds, often reaching thousands of kilometers per second. The black hole discovered by Hubble, for instance, was moving at around 4.8 million kilometers per hour. If a similar object were on a collision course with our solar system from, say, 100 million light-years away, we might have millions of years before it reached us. That sounds like a long time, but in cosmic terms, it's barely the blink of an eye. Even if we had millions of years to prepare, the challenge would be figuring out its path early enough to do anything about it. Black holes are notoriously difficult to detect, especially if they are not actively consuming matter. If the runaway black hole was moving through the intergalactic void, far from stars and gas clouds, it could be nearly invisible until it was too close to do anything about it. We might not notice it until it started influencing the motions of distant objects in our galaxy. And once it reached the outskirts of the Milky Way, things would escalate quickly. As it approached, it could begin distorting the galactic disk, altering the orbits of stars in ways that might take centuries to fully understand. But by the time we confirmed that something massive was approaching, it would already be too late to change its course. The entire structure of the Milky Way could be disrupted. Stars flung from their orbits. Planets torn from their solar systems. And the black hole itself would continue on its relentless path, consuming or distorting everything in its way. Theoretically, if a runaway supermassive black hole were heading directly toward us, our best hope for survival wouldn't be stopping it, because that would be impossible, but escaping it. That, however, presents its own set of problems. Humanity is nowhere near capable of interstellar travel, let alone intergalactic escape. Even if we had thousands of years to develop the necessary technology, it's unclear if we could evacuate Earth before such a cataclysmic event. Would we attempt to move the entire planet? That seems beyond our current, or even future capabilities. Would we send out massive space arcs, hoping to establish a new home elsewhere? Even then, where would we go? The thought of an unstoppable force like this is terrifying because it forces us to confront the reality of our cosmic vulnerability. For all our advancements, for all our knowledge, there are forces in the universe that we cannot control or predict. Black holes are among the most enigmatic of these forces, capable of rewriting the very fabric of space and time. And yet, despite their destructive power, they also hold the key to some of the greatest mysteries in the cosmos. They challenge our understanding of physics, bending the rules of reality in ways that defy common sense. Inside a black hole, the known laws of the universe break down. Time itself slows to a crawl. Matter is crushed to an infinitesimal point. What happens beyond the event horizon remains one of the greatest unanswered questions in all of science. Could runaway supermassive black holes be more than just cosmic threats? Could they, in some way, be connected to the fundamental workings of the universe? Some scientists have speculated that black holes might be gateways to other regions of space, or even other universes. If that were true, then runaway black holes wouldn't just be cosmic destroyers. They could be cosmic travelers, crossing the boundaries of existence itself. We have only begun to scratch the surface of what black holes are, and what they might be capable of. But one thing is clear, the universe is not a static, unchanging place. It is dynamic, violent, and unpredictable. Somewhere out there, a supermassive black hole is moving, unseen, on a course that may one day bring it close to us. Will we be ready? Or will we, like so many before us, be at the mercy of forces far beyond our control? If a runaway supermassive black hole is already on its way, how close would it need to get before we started seeing real, undeniable effects? The first warning signs would likely come from deep space, where astronomers track the motion of distant stars. One of the earliest indicators could be subtle gravitational lensing, where the immense gravity of the black hole bends light from stars behind it, causing them to shift in unexpected ways. This phenomenon is already used to detect exoplanets and distant galaxies, but in the case of a runaway black hole, it could be an early sign of its impending approach. As it gets closer, its gravitational pull would start distorting the Milky Way itself. Stars near the galactic core might begin drifting out of their usual orbits. Entire clusters of stars could be thrown into chaotic motion. Some would be ejected into deep space, flung away at speeds so high that they would never return. Others might collide, triggering massive supernovae that light up the sky like never before. The very structure of our galaxy, the spiral arms, the distribution of stars, even the invisible halo of dark matter, could be reshaped in unpredictable ways. Eventually, the black hole would reach the outskirts of our solar system. If it passed close enough, the first thing it would do is disrupt the Oort cloud, the vast shell of icy bodies that surrounds our solar system. This could send countless comets hurtling toward the inner planets, bombarding Earth and other worlds with impacts on a scale not seen since the age of the dinosaurs. The night sky would be filled with streaks of fire as these comets burned up in Earth's atmosphere, while larger ones could strike the surface, causing devastation on a planetary scale. But the real danger would come if the black hole moved even closer. As it approached, its gravitational influence would begin distorting the orbits of planets. Mercury, Venus, Earth, and Mars might all start shifting from their usual paths, causing dramatic climate changes. The Moon's orbit could be destabilized, leading to massive tidal waves and earthquakes. And if the black hole came close enough to the Sun, it could disrupt the delicate balance that keeps our star stable. The Sun might be pulled slightly off-center, altering its fusion processes and potentially causing it to eject enormous solar flares, blasts of radiation that could strip away Earth's atmosphere and make the planet uninhabitable. The terrifying part is that this process wouldn't happen instantly. It could take years, decades, or even centuries, during which humanity would be forced to watch as the end drew closer. Governments would scramble to find solutions, but what could we possibly do against a force that bends space and time itself? Evacuating Earth would be nearly impossible, and even if we managed to escape into space, where would we go? A supermassive black hole could easily disrupt entire star systems, making any nearby refuge just as dangerous as staying put. And then, if the black hole entered our solar system directly, it would be game over. Planets would be torn from their orbits. Some might be swallowed whole, while others would be flung into the depths of interstellar space, doomed to drift forever in the cold darkness. The Sun itself could be stripped of its outer layers, collapsing into a white dwarf, or even being consumed entirely. And Earth? If we were unlucky enough to be caught in the black hole's gravitational pull, we would experience spaghettification, the horrifying process where an object's gravity is so strong that it stretches anything that falls into it into long, thin strands. From an outside observer's perspective, Earth would appear to slow down as it approached the event horizon, frozen in time as light from our planet was stretched and redshifted beyond recognition. But for those on the surface, time would continue normally, until we crossed the point of no return. Inside the black hole, we would have no idea what was happening. Would we be crushed into an infinitely small point? Would we be transported somewhere else? Would we even experience anything at all? Science has no clear answers. What we do know is that, once inside, there would be no escape. Everything we've ever known, our history, our very existence, would vanish, erased from the universe as if we had never been. And yet, somewhere beyond the event horizon, the matter and energy that once made up our world would still exist in some form, hidden from the rest of the cosmos. But what if this has already happened before? Could entire civilizations, entire galaxies, have been swallowed by runaway black holes, their existence erased with no trace left behind? The more we study black holes, the more we realize that they may be one of the most powerful forces in the universe, not just as destroyers, but as cosmic gatekeepers to mysteries beyond our understanding. And if a runaway supermassive black hole is out there, moving silently through the darkness of space, heading toward us at unimaginable speeds, then one day, we might face the same fate. The question is, will we see it coming in time? And if we do, will there be anything we can do to stop it? If a runaway supermassive black hole were on a direct collision course with our solar system, what would our last days look like? Long before the event horizon reached us, before the point of no return, reality itself would start to unravel. Gravity would distort in ways we've never experienced. Time dilation, an effect predicted by Einstein's theory of relativity, would become noticeable. The closer something got to the black hole, the slower time would appear to move for it relative to an outside observer. From Earth, we might see entire planets stretch, slow down, and fade into darkness before vanishing entirely. The sky would no longer look familiar. As the black hole's gravitational field bent and warped light from distant stars, the constellations we've known for millennia would distort beyond recognition. Some stars might appear duplicated. Others would seem to be in the wrong place entirely. A massive, dark void, blacker than the blackest night, would loom in the sky, swallowing everything behind it. The sun's light would start to warp as well. Depending on how close the black hole came, our daylight might take on a strange, eerie appearance, reddened or even dimmed by gravitational lensing. The Sun's own orbit could be disrupted, potentially causing catastrophic climate shifts. Imagine a world where the Sun suddenly moved in an unpredictable pattern, throwing off seasons, destabilizing weather, and turning Earth's environment into an apocalyptic nightmare long before we even reach the event horizon. And then, as the black hole finally arrived, Earth would face its ultimate fate. If we were lucky, it would pass close enough to fling us out of the solar system rather than consuming us directly. In that scenario, we would become a rogue planet, drifting endlessly through the void, frozen and lifeless as we left our sun behind. But if we were unlucky, if we strayed too close to the black hole's grasp, we would experience the most nightmarish fate imaginable: spaghettification. The closer an object gets to a black hole, the stronger the gravitational pull becomes. But the pull is not uniform. It's significantly stronger at the closest point than at the farthest. For an entire planet like Earth, this means that one side would be pulled with far more force than the other, stretching it into an unrecognizable shape. First, our oceans would lift into enormous tidal waves, stretching toward the black hole like liquid fingers. Then, the crust itself would begin to deform, torn apart by forces stronger than anything we've ever encountered. Mountains would flatten, continents would split, and the very core of the planet would be exposed. As Earth spiraled inward, it would break apart into smaller and smaller fragments. Cities, forests, oceans, everything we've ever known would be reduced to streams of glowing matter, stretching impossibly thin as they wrapped around the black hole in an accretion disk. This glowing disk of doomed material would radiate immense energy, briefly shining brighter than entire galaxies before vanishing into the abyss. For anyone observing from a safe distance, Earth's final moments would be surreal. Time dilation would cause our descent to appear slower and slower until, from the outside, it would look as though we were frozen at the edge of the event horizon forever. But for those falling in, time would continue as normal, until the moment we crossed the threshold and reality itself ceased to make sense. What happens inside a black hole is one of the greatest mysteries of physics. Do we collapse into a singularity, crushed into an infinite density where the laws of physics break down? Do we somehow emerge elsewhere, in another universe, another timeline, another dimension? The truth is, we don't know. Every equation we have fails beyond the event horizon, leaving us with nothing but speculation. But what if we could find out before it was too late? What if, instead of being passive victims of a cosmic disaster, we became the first civilization to truly understand what lies beyond the veil of a black hole? What if the first humans to cross an event horizon did so not by accident, but by design? Some physicists believe that black holes might hold the key to understanding the very fabric of the universe. They may be linked to wormholes, pathways through space-time that could allow travel to other regions of the cosmos. They might even store information, holding a record of everything they have ever consumed in a way we have yet to comprehend. If we could develop the technology to study black holes up close, to probe their secrets without being destroyed, we might unlock knowledge that changes everything. And yet, runaway supermassive black holes remain an unstoppable force. Even if we learn to understand them, to predict their movements, we may never be able to stop them. They will continue their journeys across the universe, silent titans of destruction, rewriting the fate of galaxies wherever they go. Somewhere, right now, one of these black holes is moving unseen through the darkness. Perhaps it will pass harmlessly through empty space, never encountering another star system. But perhaps, one day, it will set its sights on us. When that day comes, will we be ready? Or will we simply be another forgotten casualty of the cosmic dance, lost to history, swallowed by the darkness, never to be seen again? If a runaway supermassive black hole were approaching, our best hope would be to detect it as early as possible. But how soon would we even know? Unlike planets or stars, black holes don't emit their own light. They are, by definition, invisible. We can only detect them indirectly, by observing their gravitational effects on surrounding objects, or by spotting the radiation given off when they interact with matter. This means that if a supermassive black hole were barreling toward us through the vast emptiness of intergalactic space, there's a chance we might not see it until it was dangerously close. Some scientists argue that with our current technology, We might only notice a rogue black hole when it was already within a few thousand light-years of Earth. That sounds like a safe distance, but in cosmic terms, it's uncomfortably close. If it's moving fast enough, that could give us only a few million years, or even less, to prepare. That might sound like plenty of time, but when you consider the scale of the problem, it's barely the blink of an eye. What would we do if we detected one on a collision course with our galaxy? The first response would be scientific study. Astronomers would scramble to refine their calculations, determining its exact trajectory, speed, and estimated arrival time. There would be no immediate panic. At first, the danger would feel too distant, too theoretical. After all, even if a supermassive black hole were headed our way, it could take hundreds of thousands, or even millions, of years to reach us. But as the years passed and the reality of our situation set in, humanity would be forced to ask a terrifying question: can we escape? This is where things get complicated. If we knew that a supermassive black hole would inevitably destroy Earth, our only hope for survival would be to leave the planet behind. But where would we go? Even the closest potentially habitable exoplanets are light years away. With our current technology, interstellar travel is completely beyond our reach. We would need to develop entirely new propulsion systems, perhaps harnessing nuclear fusion, antimatter, or even the warping of space-time itself, just to have a chance of reaching a new home in time. But even if we solved the problem of travel, we would face an even greater challenge: scale. Evacuating billions of people from Earth would require an effort beyond anything humanity has ever attempted. Who would get to go? How would we choose? Would governments and corporations control the evacuation, or would it be a free-for-all, with the wealthiest securing their survival while the rest of humanity was left behind? And then there's the question of whether it would even be possible to escape at all. If the black hole was approaching at relativistic speeds, close to the speed of light, it could reach us far sooner than we expect. Even if we had millions of years, it might not be enough. Space travel is incredibly difficult, and the odds of successfully relocating even a small fraction of the population to another star system are slim. But what if, instead of running, we tried to fight back? Could we somehow stop a runaway black hole? The idea seems absurd. Black holes consume everything in their path, bending space and time itself. But some physicists have theorized that there might be ways to manipulate them. If we could harness the power of artificial gravity, or even tap into the strange quantum effects at the heart of black hole physics, we might be able to deflect its path or even destroy it. One idea involves using energy to push or redirect the black hole. If we could direct a massive stream of radiation or another powerful force, perhaps even harnessing the energy of a star, we might be able to alter its course. Another possibility is using gravitational interactions with other celestial bodies to nudge it away, though this would require precise calculations and an enormous amount of time. Of course, these ideas are purely theoretical. We have no real way of testing them, and the forces involved are so incomprehensibly vast that even our best technology might be completely powerless. In the end, a runaway supermassive black hole is one of the few cosmic threats that might be truly unstoppable. And if we can't stop it, then what? The only thing left to do would be to witness the end. To watch as our planet, our solar system, and everything we've ever known is slowly consumed by an unstoppable force from the depths of the universe. Would we spend our final years in a desperate race to escape? Would we resign ourselves to fate, recording our last moments in the hope that some future civilization might one day find the remnants of our existence? Or would we simply live as if nothing was happening, enjoying the time we have left before the darkness takes us? Maybe it doesn't matter. Maybe the universe is full of runaway black holes, moving silently through the void, rewriting the fate of galaxies without us even knowing. Maybe one is already on its way. And maybe, just maybe, we'll never see it coming. If a runaway supermassive black hole is already on its way, hidden somewhere in the vast darkness of space, what are the chances that we'll detect it before it's too late? The terrifying truth is that we might not. Unlike stars or galaxies, black holes emit no visible light. They don't glow, they don't reflect, and they don't announce their presence in any way we can easily detect. The only reason we know they exist at all is because of the way they interact with their surroundings. They warp light from distant stars, they send gravitational waves rippling through the fabric of space-time, and when they consume matter, they produce bursts of high-energy radiation. But a runaway supermassive black hole, one that isn't actively feeding, could slip through space almost completely undetected. A black hole with no surrounding accretion disk, no bright X-ray emissions, and no nearby objects being torn apart wouldn't leave any obvious clues. If one were moving toward us through intergalactic space, it might not be surrounded by the glowing, swirling clouds of superheated gas that make other black holes visible. Instead, it could be as dark as the void itself, a cosmic bullet speeding silently through the universe. The only way we might detect such an object is through its gravitational influence. If it passed close enough to distort the orbits of stars in the Milky Way, astronomers could notice something was wrong. They might see stars moving in strange, unexpected ways, their paths subtly altered by an unseen force. But by the time those changes were detected and analyzed, it could already be too late to do anything about it. Some scientists believe that the best way to detect rogue black holes is to look for the way they bend and distort light from background stars, a phenomenon known as gravitational lensing. When a massive object passes in front of a distant star, its gravity acts like a lens, bending and magnifying the star's light. If astronomers carefully monitor the sky for these lensing events, they might be able to identify rogue black holes moving through the galaxy. But even with these methods, we could still miss one. Space is unimaginably vast, and even the most advanced telescopes can only observe a fraction of it at any given time. A supermassive black hole moving toward us from an unexpected direction, perhaps from deep within an uncharted region of intergalactic space, could remain invisible until it was close enough to start affecting our solar system directly. And at that point, our fate would already be sealed. So, let's assume the worst-case scenario. A runaway supermassive black hole is heading straight for our solar system, and we detect it far too late to escape or stop it. What happens next? The first sign would likely be disruptions in the orbits of the outer planets. Long before the black hole reached us, its gravity would start to influence the movements of objects in the Kuiper Belt, the vast, icy region beyond Neptune. Dwarf planets like Pluto and Eris might begin to shift in their orbits, their paths subtly altered by the black hole's gravitational pull. These changes would be small at first, almost imperceptible. But as the black hole drew closer, the effects would grow stronger. Next, the gas giants, Jupiter, Saturn, Uranus, and Neptune, would begin to feel the strain. Their orbits, which have remained stable for billions of years, would start to wobble. Depending on the black hole's trajectory, some of these planets might be pulled closer to the Sun, while others could be flung out into the darkness of interstellar space. Then, the asteroid belt between Mars and Jupiter would be thrown into chaos. The delicate balance that keeps thousands of space rocks in stable orbits would be shattered, sending countless asteroids hurtling in all directions. Some might crash into other planets, triggering cataclysmic impacts. Others might be drawn toward the Sun, vaporizing in fiery streaks as they enter its corona. And a few, perhaps more than a few, could be sent hurtling straight toward Earth. But asteroid impacts would be the least of our worries. By the time the black hole reached the inner solar system, its gravitational pull would be so immense that entire planets could be ripped apart. The Moon, which has orbited Earth for over 4 billion years, might be torn from our planet's gravitational grasp. Without the Moon's stabilizing influence, Earth's axial tilt could become wildly unstable, causing climate chaos on a scale we can't even imagine. Seasons would shift unpredictably, temperatures would fluctuate wildly, and weather patterns would spiral into complete disorder. And then, as the black hole drew closer, Earth itself would face its final moments. The exact nature of our planet's destruction would depend on how close we came to the event horizon. If we were lucky, the black hole might simply fling us out of the solar system, turning Earth into a frozen rogue planet drifting through the void. But if we were unlucky, if we crossed too close to the point of no return, we would be stretched and torn apart, reduced to a thin stream of superheated matter spiraling into the abyss. From a cosmic perspective, this would be just another event in the endless cycle of destruction and creation that has shaped the universe for billions of years. Our entire history, every civilization, every achievement, every moment of human existence, would vanish without a trace, consumed by a force beyond our comprehension. And yet the universe would go on. The stars would continue to shine, galaxies would continue to collide, and somewhere, on some distant world, life might still exist, completely unaware that we were ever here. But what if this isn't the end? What if there's a way to survive, even in the face of annihilation? Some scientists speculate that black holes might not be the ultimate dead ends we think they are. Instead of simply destroying everything they consume, they might act as gateways to other regions of the universe. Some theories suggest that black holes could be connected to white holes, hypothetical objects that expel matter instead of absorbing it. If this is true, then falling into a black hole might not mean being crushed into oblivion. It might mean emerging somewhere else, in a different part of the cosmos, or even in a completely different universe. Could this be our way out? Could we harness the power of a black hole to escape the fate of our solar system? Right now, the idea is pure speculation. But if we ever develop the technology to explore black holes up close, we might uncover secrets that change everything we thought we knew about space, time, and the nature of reality itself. For now, all we can do is watch the sky and hope that if a runaway supermassive black hole is out there, heading our way, we see it before it's too late. But if we don't, if one is already on its way, unseen and unstoppable, then maybe, just maybe, we'll never know what hit us. The terrifying reality is that a runaway supermassive black hole wouldn't need to come anywhere near Earth to destroy us. Even if it passed hundreds of light years away, the sheer gravitational disruptions it could cause might be enough to throw our entire solar system into chaos. Imagine a silent force creeping through the galaxy, completely invisible until it's too late, reshaping the fabric of space itself. Entire star systems could be displaced, planets ripped from their orbits, and cosmic structures that have stood for billions of years could be undone in an instant. One of the most chilling possibilities is that a rogue black hole could completely destabilize the Milky Way as we know it. If it were moving fast enough and approached the dense core of our galaxy, it could trigger a chain reaction of gravitational disturbances that might even affect the supermassive black hole at the center of our own galaxy, Sagittarius A star. This could lead to an eruption of energy unlike anything our species has ever witnessed, a cataclysmic event on a galactic scale. Even if our planet wasn't directly consumed, the aftershocks of such an event could result in extreme bursts of radiation, cosmic explosions, and a new era of galactic chaos. But even outside of that worst-case scenario, what if a supermassive black hole simply passed close enough to slightly alter the Sun's position in the galaxy? The Sun orbits around the center of the Milky Way in a stable pattern, but if a rogue gravitational force threw it off course even slightly, it could send our solar system on a completely new trajectory, one that might take us into deadly regions of space. We could be hurled toward dense star clusters filled with high-energy radiation, toward supernova remnants spewing out deadly cosmic rays, or even straight into the path of another black hole. And let's not forget the long-term effects. If the Sun's position were altered, it might change Earth's distance from the Sun just enough to completely disrupt our climate. A slight shift inward, and our planet could heat up beyond survivability, turning into a second Venus, where temperatures soar high enough to melt lead. A slight shift outward, and Earth could become a frozen wasteland like Mars, its oceans locked beneath thick layers of ice. The delicate balance that allows life to exist here is so precise that even the smallest gravitational nudge could be enough to render our world uninhabitable. But what if we're already too late? What if a rogue supermassive black hole is already altering the structure of our galaxy, and we just haven't noticed yet? It's entirely possible that the effects of one are already in motion, subtly warping the paths of stars and planets in ways that won't be noticeable for thousands, or even millions of years. If that's the case, then by the time we realize what's happening, there may be nothing we can do to stop it. Right now, astronomers are scanning the skies, searching for anomalies that might indicate the presence of an unseen force moving through the cosmos. They're looking for stars that are being unexpectedly displaced, for mysterious gravitational lensing effects, for unexplained shifts in galactic structures. But space is so vast, and our technology is still so limited, that we might never truly know if something is coming for us until it's too late. The only real hope for humanity might be to advance far enough in space travel that we aren't dependent on just one planet for survival. If we remain confined to Earth, then any cosmic disaster, whether it's a black hole, an asteroid, or even the eventual death of the Sun, is guaranteed to wipe us out eventually. The only way to ensure the long-term survival of our species is to expand beyond our home world, to establish colonies on other planets, to spread across the galaxy in a way that makes us less vulnerable to extinction. But even that wouldn't be a perfect solution. If a rogue black hole were powerful enough, it wouldn't just threaten one planet or one solar system. It could potentially threaten entire sections of the galaxy. The only real way to survive would be to develop the ability to move not just from planet to planet, but from star system to star system, even from galaxy to galaxy. And that's assuming we could ever develop the technology to do so before an event like this happens. So where does that leave us? Are we doomed, or do we have a fighting chance? The truth is, we just don't know. We're still in the early stages of understanding the true nature of black holes, and even though we've made incredible discoveries in recent years, we still have more questions than answers. We don't know how many rogue black holes are out there. We don't know how fast they're moving. We don't know if one is heading straight for us right now. But maybe, just maybe, if we keep looking, if we keep searching, we might find the answers before it's too late. Because if we don't, if we let our guard down, if we assume we're safe just because nothing has happened yet, then we might be in for the most terrifying surprise the universe has to offer. The scariest part of all this is that we wouldn't even see it coming. A supermassive black hole doesn't emit light. It doesn't glow like a star or burn like a nebula. It moves through space as a silent, invisible force, bending reality itself without giving away its position. The only way to detect it is by observing how it affects other objects in space, how it distorts the light of stars behind it, how it pulls celestial bodies out of their expected orbits, how it leaves behind trails of destruction in regions where something massive should exist but remains unseen. But even with our best telescopes, we can only see so much of the universe. Space is unimaginably vast, and a rogue supermassive black hole could be anywhere, moving at speeds so high that by the time we detect its effects, it may already be dangerously close. And if one were heading toward us, how much warning would we get? If it were still millions of light years away, astronomers might notice unusual gravitational disturbances in deep space. They might see distant galaxies behaving strangely, their stars subtly shifting in ways that can't be explained. But at that distance, it would still be nothing more than a mystery, an anomaly to be studied. By the time it entered our own galaxy, the distortions would become more obvious. Entire star systems could be seen moving unpredictably. Astronomers might suddenly notice a growing gap in their maps of space, a region where everything appears to be getting pulled in one direction without explanation. But if it were much closer, say, just a few thousand light years away, the warnings could be terrifyingly short. The gravitational pull of a supermassive black hole is so powerful that it can affect objects across immense distances. If one were on a trajectory toward us, the first sign might not be visual at all. It might be a disruption in the orbits of stars in our region of the Milky Way. Planets in distant solar systems could start to wobble, their motions thrown off by an unseen force. The stars themselves might begin drifting in ways that astronomers struggle to explain. And if the black hole were only a few hundred light years away? That's where things would get truly apocalyptic. At that range, its gravitational effects could begin altering our own solar system. The Oort cloud, the vast, distant shell of icy objects surrounding our system, could be disturbed, sending countless comets inward toward the Sun. Some of these icy bodies could collide with planets, creating massive impacts. Others might hit Earth directly, causing catastrophic destruction on a scale we haven't seen since the asteroid impact that wiped out the dinosaurs. Meanwhile, the orbits of the outer planets could start to shift. Neptune and Uranus, the distant ice giants, might be pulled ever so slightly from their paths. And that change would ripple inward. The balance of the entire solar system is delicate, held together by the precise interplay of gravity between the Sun and all its planets. A disturbance, even a small one, could create chaos. Jupiter, the largest planet in our solar system, plays a crucial role in stabilizing Earth's orbit by acting as a gravitational shield, pulling in many of the asteroids and comets that could otherwise threaten us. But if a rogue supermassive black hole's gravitational pull affected Jupiter's position, it could throw the gas giant into a new orbit, one that no longer protects us. If that happened, Earth could become far more vulnerable to cosmic impacts. Worse still, if the black hole's gravity affected the Sun itself, our entire solar system could be dragged off course. The Sun follows a specific path through the galaxy, orbiting the Milky Way's center over the course of hundreds of millions of years. If that path were altered, our solar system could be thrown into a dangerous new trajectory, one that might take us into regions of space filled with deadly radiation, unstable stellar remnants, or even direct collisions with other star systems. In the worst-case scenario, the Sun could be pulled so far from its stable orbit that it enters the gravitational reach of the black hole itself. And if that happened, there would be no escape. A runaway supermassive black hole doesn't just consume matter, it warps time and space itself. As objects fall toward its event horizon, they experience time dilation, meaning that from an outside perspective, they appear to slow down infinitely as they approach the point of no return. If the Sun were ever pulled into such a fate, it would be stretched and torn apart, its plasma spiraling into a luminous, chaotic accretion disk as it was consumed. And without the Sun, Earth would instantly become a frozen wasteland. The atmosphere would collapse. The oceans would solidify into endless sheets of ice. Life would vanish almost immediately, leaving behind a world of silence and darkness, drifting through space with no future. But here's the terrifying question: what if a rogue black hole has already altered our solar system in ways we don't yet understand? What if some of the unexplained anomalies in our astronomical observations, like the strange, seemingly random movements of certain distant stars, are actually signs that something massive and unseen is already influencing our part of the galaxy? What if we're already caught in the gravitational reach of an invisible force that is slowly but inevitably pulling us toward an unknown fate? And what if the black hole that's coming for us isn't just any black hole, but one that's millions of times the mass of our Sun, moving at thousands of kilometers per second, tearing through the fabric of reality itself? If that were true, then the scariest part of all is that we wouldn't be able to do anything about it. Because no amount of technology, no level of scientific advancement, no interplanetary escape plan could save us from something that bends the very nature of time and space. So maybe the question isn't whether we'll be affected by a runaway supermassive black hole, but whether we'll realize it before it's too late. Because if one is already coming for us, if one is already creeping toward our solar system, then there's nothing we can do but wait. And by the time we see its effects, by the time we notice the stars shifting in ways we can't explain, by the time we feel its pull on our own Sun, it may already be too late. The terrifying reality of a runaway supermassive black hole is that by the time we notice its effects, our fate might already be sealed. Space is vast beyond human comprehension, and even though we've mapped a significant portion of our galaxy, there are countless regions we haven't observed in detail. Supermassive black holes don't emit light, and unless they are actively consuming matter, they remain invisible against the backdrop of space. This means one could already be headed in our direction, and we wouldn't know until its gravitational pull started warping the orbits of celestial objects within our own galactic neighborhood. Imagine for a moment that a team of astronomers suddenly notices an unexplained movement in the stars. It starts as a subtle shift, something that could be dismissed as a mere error in measurement. But then, as they track it over time, the anomaly becomes more pronounced. Stars that should be following predictable orbits around the Milky Way's center are slightly deviating, moving in ways that contradict our understanding of gravity. At first, it's a mystery, something that sparks scientific debate, leading to discussions about dark matter, gravitational waves, or some other cosmic phenomenon. But then, as the data piles up, the horrifying realization sets in. Something massive, something beyond anything we've detected before, is approaching. Once the existence of a rogue supermassive black hole is confirmed, the first question would be, how far away is it? If it's millions of light-years distant, we might have thousands or even millions of years before it poses a direct threat. But if it's within our own galaxy, say, a few 100,000 light-years away, then the timeline for catastrophe could be much shorter. If it's within just a few thousand light-years, we might already be feeling its effects. At this point, astronomers would be working frantically to determine its trajectory. If it's merely passing by our galaxy, it might not be a direct threat. But if it's heading toward the Milky Way's center, or worse, toward our own solar system, then every scientific effort would shift toward understanding what, if anything, could be done. The answer, unfortunately, would likely be nothing. A supermassive black hole is not like an asteroid or a comet. We can't deflect it, we can't destroy it, and we certainly can't outrun it. It moves at unimaginable speeds, driven by the gravitational interactions of galaxies themselves, and anything that gets in its way is doomed. If this black hole were close enough to influence the outer edges of our solar system, we would see its effects long before it reached us. The Oort cloud, a vast region of icy bodies at the edge of our solar system, would be the first to feel its presence. These distant objects, which are barely held in place by the sun's gravity, could be sent hurtling inward. A sudden increase in comets and asteroids entering the inner solar system would be one of the earliest signs of impending disaster. As the black hole drew closer, its gravitational force would start to affect the orbits of the planets. At first, the changes would be small, tiny deviations in their paths, barely noticeable over short periods. But over decades or centuries, those small deviations would accumulate, destabilizing the delicate balance that keeps our solar system in harmony. Some planets might drift into new orbits, while others could be ejected entirely, flung into the void of interstellar space. And Earth? Earth could be pulled out of its life-sustaining orbit around the Sun, thrown into a trajectory that either sends it hurtling into deep space, where it would freeze into an icy wasteland, or dragging it closer to the Sun, where it would be scorched into a barren, lifeless rock. But the worst-case scenario is if the black hole comes close enough to the Sun itself. If it were to pass near our solar system, the Sun's gravitational hold on the planets could be disrupted entirely. The immense gravitational influence of the black hole could begin pulling the Sun off course, altering its motion through the galaxy. This wouldn't just change our solar system's position, it would affect the very foundation of life on Earth. Even slight shifts in the Sun's position relative to the Milky Way could expose our planet to new cosmic dangers, such as increased exposure to deadly radiation or collisions with other stellar objects. And if the black hole were to come even closer? If it were to approach within a few light years of the Sun, the sheer force of its gravity could begin pulling solar material away. The Sun's outer layers could be stripped, its energy output could fluctuate, and the very process that sustains life on Earth, stable solar radiation, could be thrown into chaos. Without a stable Sun, Earth's climate would be doomed. A sudden loss of solar energy could trigger a rapid ice age, while an increase in solar instability could make the planet uninhabitable. But let's push this scenario to its absolute extreme. Let's say this runaway supermassive black hole isn't just passing through, it's heading directly for our solar system. As it nears, its gravitational pull would become overwhelming. The planets would be thrown into violent, unpredictable orbits. The asteroid belt between Mars and Jupiter would be disturbed, sending countless chunks of rock and metal careening toward Earth. The gas giants, Jupiter and Saturn, could be ripped apart, their atmospheres torn away and absorbed into the black hole's accretion disk. By the time the black hole reaches within a few light days of our system, its presence would dominate the sky. We wouldn't see it directly, but we'd see its effects. Light from distant stars would warp and bend around it, creating bizarre optical distortions. The night sky would become an eerie, shifting illusion, with patches of darkness where stars should be. As it got closer, Earth itself would start to experience strange gravitational anomalies. The pull of the black hole could cause violent earthquakes, disrupt the tides, and create massive shifts in the planet's crust. And then, the final moment would arrive. If the black hole came close enough, Earth would be pulled directly into its grasp. The planet would begin to stretch and distort, its mass spiraling inward in an ever-tightening vortex. From the perspective of an outside observer, Earth would appear to slow down as it approached the event horizon, frozen in time as it was consumed. But from our perspective, everything would end in an instant. The very fabric of reality would tear apart as we crossed into the black hole's point of no return. Time would cease to function, space itself would collapse, and everything that ever existed on this planet, all of human history, every thought, every dream, would be erased, consumed by a cosmic force beyond our comprehension. And the scariest part? This could already be happening. Somewhere out there, in the vast, uncharted depths of space, a runaway supermassive black hole could be heading toward us. Maybe it's millions of years away. Maybe it's closer than we think. Maybe, right now, at this very moment, the fate of our entire solar system has already been sealed, and we're just waiting for the first signs of the inevitable. The terrifying reality of space is that it operates on timescales far beyond human comprehension. Catastrophic events, like galaxies colliding, stars being torn apart, or supermassive black holes running loose, can take millions or even billions of years to unfold. But from our limited perspective, we may only detect them when it's already too late. A runaway supermassive black hole could be silently approaching, hidden in the darkness, completely undetectable until its gravitational influence begins to warp the stars around it. And even then, by the time we realize what's happening, there may be no way to escape its pull. If a supermassive black hole were heading toward us, astronomers would first notice its effects on distant objects. Stars on the outskirts of our galaxy might start behaving erratically, shifting in ways that contradict expected gravitational patterns. At first, this might be dismissed as some unknown cosmic phenomenon. But as more data is gathered, a horrifying pattern would emerge. Something massive, something unseen, is moving through space, distorting everything in its path. The sheer scale of a supermassive black hole makes it one of the most unstoppable forces in the universe. These objects can contain millions or even billions of times the mass of the Sun, packed into an incredibly dense singularity. Their gravitational pull is so intense that nothing, not even light, can escape once it crosses the event horizon. And when one of these behemoths is in motion, tearing through interstellar space, it doesn't just passively drift, it actively consumes anything in its path. Entire star systems can be disrupted, planets ripped from their orbits, gas clouds siphoned into its swirling accretion disk, heating up as they spiral inward, glowing with the energy of 1,000 suns before vanishing forever. If a runaway supermassive black hole were on a direct collision course with our galaxy, its effects would be felt long before it reached us. First, the outermost stars of the Milky Way would begin to shift, their orbits subtly changing as they felt the distant tug of an unseen force. As the black hole moved closer, these disturbances would become more dramatic. Some stars might be pulled completely out of our galaxy, flung into intergalactic space as the immense gravity of the black hole disrupted their trajectories. Others might be drawn directly toward the black hole itself, spiraling inward in a fiery demise. The black hole wouldn't just consume stars, it would distort the very fabric of space-time around it. Light from distant galaxies would bend and twist as it passed near the black hole's gravitational field, creating bizarre optical illusions. Entire regions of space might appear warped or stretched, as if reality itself were bending. And for any planets unfortunate enough to lie in its path, there would be no escape. As the black hole continued its relentless march, it would begin to affect the inner regions of the Milky Way. Gas clouds, the building blocks of future stars, would be disrupted, preventing new stars from forming. The delicate balance of our galaxy's gravitational structure would begin to unravel. And then, as it drew even closer, it would reach the densely packed core of the Milky Way, where the supermassive black hole that already exists at the center of our galaxy resides. What happens when two supermassive black holes collide? The answer is one of the greatest mysteries of astrophysics. The most likely outcome is that they would enter into a death spiral, orbiting each other at increasing speeds, warping space-time itself as they drew closer together. The energy released in such an event would be beyond comprehension. Gravitational waves, ripples in the very fabric of space, would radiate outward, distorting everything in their path. The final moments of this cataclysmic event would be marked by a burst of unimaginable power, as the two black holes merged into one, forming an even larger, even more destructive entity. But let's take a step back. What if this runaway black hole isn't just a threat to the galaxy as a whole? What if it's heading directly for our solar system? The first signs would be subtle. Perhaps astronomers would notice an unexpected increase in comet activity, as distant objects from the Oort cloud, normally stable in their icy orbits, begin to get knocked loose. Then, over time, the orbits of the outer planets would start to shift. Neptune and Uranus, the ice giants at the edge of our system, would deviate slightly from their expected paths. These changes would be small at first, but they would grow over time. Jupiter and Saturn, the gas giants that help protect the inner planets from cosmic debris, would feel the pull next. Their orbits would stretch and distort, and their immense gravity, normally a stabilizing force for the solar system, might instead become chaotic. If Jupiter were thrown off balance, the asteroid belt between Mars and Jupiter could become unstable, sending waves of space rocks hurtling inward. Earth, caught in the middle of this celestial turmoil, would have no way to avoid the chaos. But the worst part wouldn't be the asteroids or the comets. It would be what happens when the black hole gets close enough to influence the Sun itself. Our Sun, the source of all life on Earth, is bound by the delicate gravitational balance that keeps it in motion around the Milky Way. If a supermassive black hole approached, this balance would be disrupted. The Sun might be pulled slightly off course, throwing the entire solar system into disarray. A slight change in the Sun's trajectory could mean the difference between Earth remaining habitable or becoming an unrecognizable wasteland. If the black hole came close enough, the Sun itself could start losing material. Its outer layers could be stripped away, forming a swirling disk of superheated plasma as they spiral toward the black hole. Solar storms would become more intense, sending waves of radiation surging toward Earth. The planet's magnetic field, which protects us from deadly solar winds, might not be able to withstand the increased energy. The atmosphere could begin to erode, exposing the surface to the full fury of space. And if the black hole were to come even closer? If it were to enter the solar system itself? The planets would be pulled from their orbits, thrown into chaos. Some might be swallowed whole, disappearing forever into the void. Others might be ejected entirely, flung into the darkness of interstellar space. And Earth? Earth might be torn apart by tidal forces, ripped to pieces as it spiraled toward its inevitable doom. The terrifying thing is that we wouldn't even see it coming. A black hole moving through space is nearly invisible. We can only detect them indirectly, by observing how they affect the objects around them. If a rogue supermassive black hole were heading toward us right now, we might not know until it was already too late. And by then, there would be nothing we could do. If a runaway supermassive black hole were silently making its way toward our solar system, the first sign of its approach might not even come from astronomers. It could come from the sky itself. Strange anomalies would start to appear, subtle distortions in the positions of stars, unexpected shifts in gravitational forces that could be detected by sensitive instruments but would otherwise go unnoticed. The vast emptiness of space would seem unchanged, yet hidden within the void. An object of unimaginable power would be drawing closer, warping reality itself as it moved. One of the most chilling aspects of a rogue supermassive black hole is its stealth. Unlike stars, which shine brightly, black holes emit no light of their own. Their presence is revealed only by their effects on nearby matter, their gravitational pull distorting everything in their vicinity. If one were approaching, it would likely remain undetectable until it was dangerously close. Even the most advanced telescopes might fail to spot it in the darkness, allowing it to creep ever closer, unseen and unstoppable. As it neared, the outer edges of our solar system would be the first to feel its influence. The Oort cloud, a vast region of icy bodies stretching nearly a light-year from the Sun, would experience a gravitational shift. Comets that had remained in stable orbits for billions of years would be nudged off course, sent hurtling inward toward the inner planets. At first, this might seem like a coincidence, an unusual but explainable increase in comet activity. But as more and more icy bodies were thrown toward the Sun, astronomers would begin to suspect something far more sinister at play. The gravitational pull of the rogue black hole would continue to distort the delicate balance of our solar system. As it moved closer, its influence would extend to the gas giants. Jupiter, the largest planet in our solar system, would begin to shift slightly in its orbit. These changes would be nearly imperceptible at first, detectable only with the most precise instruments. But over time, the deviations would grow, and the entire solar system would begin to experience a gravitational crisis. Saturn's rings, normally a perfectly structured system of ice and rock, would start to destabilize. Uranus and Neptune, already tilted and mysterious in their own right, would experience changes in their axial tilt, causing unpredictable shifts in their weather patterns. The icy moons orbiting these planets might be flung into chaotic paths, some crashing into their parent planets, others ejected into deep space. But the true nightmare scenario begins when the black hole moves close enough to directly impact the Sun. A supermassive black hole's gravitational pull is so intense that it can warp space-time itself, creating an effect known as frame dragging. This means that as it moves through space, it literally pulls the fabric of reality along with it. If it came close enough to our solar system, it could distort the Sun's motion through the galaxy, disrupting the very foundation of our cosmic environment. The Sun's outer layers, already turbulent with the energy of nuclear fusion, could begin to experience tidal effects from the approaching black hole. Gigantic solar flares, larger than anything ever recorded, could erupt from its surface, sending waves of radiation streaming toward Earth. These storms could overwhelm our planet's magnetic field, stripping away the upper layers of the atmosphere, exposing the surface to deadly cosmic radiation. The blue skies of Earth could darken, the air itself becoming ionized by the sheer intensity of the energy flooding in from space. If the black hole were to come even closer, the consequences would be even more devastating. The Sun itself could begin to lose mass, its gravitational hold on the planet's weakening. This would cause the orbits of Earth and its neighbors to shift unpredictably. Even a slight change in Earth's distance from the Sun could have catastrophic effects on the climate. A few million kilometers closer, and the oceans would begin to boil away. A few million kilometers farther, and the planet could freeze into a lifeless wasteland. And then, the final and most terrifying possibility: what if the black hole doesn't just pass by? What if it directly enters our solar system? In this scenario, chaos would unfold at an unimaginable scale. The planets, once locked in their stable orbits, would be thrown into complete disarray. Mercury, the closest planet to the Sun, might be pulled directly into the black hole, disappearing without a trace. Venus, already a hellscape of extreme temperatures and toxic clouds, could be thrown into a new orbit, perhaps even crashing into Earth. Earth itself would not be spared. The gravitational forces at play would be too strong for our planet to maintain its delicate balance. We could be pulled into a collision course with Mars or another planet, or worse, we could be torn apart by tidal forces. The very crust of the planet could crack and break, causing continents to shift violently, entire mountain ranges to collapse, and the oceans to surge in massive tsunamis that would sweep across the land, erasing everything in their path. But the most terrifying fate would be one in which Earth is slowly dragged toward the black hole's event horizon. As we spiral inward, time itself would begin to distort. To an outside observer, our descent would appear to slow, as if frozen in time. But from our perspective, everything would accelerate. Light from the universe would become redshifted, the stars stretching into eerie, elongated streaks. And then, as we crossed the event horizon, reality as we know it would cease to exist. No signal, no light, no information would escape. Earth would vanish, consumed in the infinite darkness, lost forever in the crushing singularity of the black hole. And the worst part? We might never see it coming. A runaway supermassive black hole isn't just a hypothetical nightmare, it's something that has been observed in deep space. Astronomers have detected evidence of these cosmic monsters being flung from their home galaxies, ejected at incomprehensible speeds, and left to roam the void between galaxies like invisible juggernauts. And if one of these is headed in our direction, the consequences would be beyond catastrophic. One of the most striking discoveries in recent years is a supermassive black hole hurtling through space at an estimated speed of 5 million miles per hour. This particular black hole, likely ejected from its galaxy due to a violent gravitational interaction, is leaving behind a trail of newly formed stars as it cuts through intergalactic space. That alone is fascinating. Black holes are generally known for their destructive power, yet this one appears to be triggering the birth of stars as it moves. It's essentially carving a streak of light across the darkness, a phenomenon that challenges our understanding of how black holes interact with their surroundings. But this also raises a terrifying question. If a supermassive black hole can be sent rocketing into space, what's stopping one from heading our way? The forces required to eject a black hole of this size are almost unimaginable. Supermassive black holes usually reside at the centers of galaxies, bound in place by the immense gravitational forces of billions of stars. But when galaxies merge, the central black holes can enter into an incredibly intense dance, spiraling around each other in a gravitational embrace that warps space and time itself. If a third black hole enters the equation, perhaps from another galaxy collision, the delicate balance is shattered. One of the black holes can be slingshot away at tremendous speeds, flung into deep space as if shot from a gravitational cannon. These runaway black holes don't just disappear into the void. Their immense gravity continues to shape the environment around them. As they pass through interstellar and intergalactic space, they can consume gas, dust, and even stars, growing larger and more dangerous. If one were to pass through a galaxy, it could wreak havoc, distorting planetary orbits, swallowing stars, and leaving destruction in its wake. If one were to come near our galaxy, the Milky Way, the consequences could be unfathomable. Astronomers estimate that there could be dozens, if not hundreds, of these rogue supermassive black holes drifting through space. Some are moving at speeds that could allow them to travel from one galaxy to another over billions of years. But that also means that, given enough time, one could eventually make its way toward us. And the truth is, we might not even realize it until it's too late. The challenge in detecting these cosmic wanderers is that they don't emit any visible light. Black holes only reveal themselves through their interactions with other objects, by consuming matter or bending the light of background stars through gravitational lensing. If a runaway black hole were headed in our direction but wasn't actively feeding on anything, it could be nearly impossible to detect. Some theories suggest that a massive unseen object may already be lurking in the outer reaches of our solar system. There have been unexplained gravitational anomalies in the orbits of distant objects beyond Pluto, anomalies that hint at the presence of something enormous, something far beyond the size of any known planet. Some have speculated that this could be an undiscovered planet, often referred to as Planet 9. But a more terrifying possibility is that these disturbances are being caused by a rogue black hole, one that has been drifting unseen through the outer solar system. If a supermassive black hole were on a direct collision course with the Milky Way, the first warning signs might not come from within our own solar system, but from deep space. Galaxies in its path would experience disruptions, their stars thrown into disarray. The black hole's immense gravity could send entire star systems spiraling into chaos, altering the structure of entire galactic arms. And as it got closer, its effects would become impossible to ignore. The Milky Way itself would feel the gravitational influence long before the black hole arrived. Star clusters on the outskirts of the galaxy might begin shifting unpredictably. The vast, rotating disk of the Milky Way could experience distortions, as if an unseen hand were tugging at its structure. The supermassive black hole at the center of our galaxy, Sagittarius A*, could even react to the approaching force, destabilizing and erupting with increased activity. And then, as it neared, the devastation would escalate to an unprecedented level. Entire regions of space could be swallowed up, stars devoured, planets ripped apart. The very fabric of reality around us could be altered as space-time itself was distorted beyond recognition. And if this rogue black hole were to enter the inner regions of our galaxy, the solar system as we know it would be doomed. The thought of Earth being pulled toward a black hole is terrifying enough. But what's even more disturbing is that we wouldn't necessarily fall straight in. The gravitational forces at play would be so immense that our planet could instead be stretched and torn apart before ever reaching the event horizon. The intense tidal forces, known as spaghettification, would elongate and distort the planet, stretching it into thin streams of matter before ultimately consuming it. And even if Earth somehow avoided direct capture, the changes to our Sun's gravitational environment would be catastrophic. The orbits of all the planets would be thrown into chaos. Earth could be ejected into deep space, sent drifting into the freezing void without a sun to provide warmth and energy. Or we could be sent hurtling into the sun itself, ending all life in an instant. What's truly horrifying is that, given the nature of these runaway supermassive black holes, we might never see it coming. It could already be on its way, drifting silently through the darkness, unseen and unstoppable. And if one ever does arrive in our cosmic neighborhood, there would be nothing we could do to stop it. The terrifying reality is that if a runaway supermassive black hole were approaching our galaxy, humanity would be completely powerless to stop it. The sheer scale of such an object is beyond comprehension. These black holes are millions or even billions of times more massive than our Sun, containing so much gravitational pull that not even light can escape. There is no technology, no weapon, and no scientific breakthrough that could prevent the inevitable consequences of such an event. The only thing we could do is observe, watch helplessly as the cosmos reshapes itself in ways we never imagined possible. But how likely is it that one of these rogue black holes is actually headed our way? Right now, astronomers estimate that there could be hundreds of these wandering giants drifting between galaxies, moving at speeds fast enough to cross vast cosmic distances over billions of years. The challenge, of course, is detecting them. Since black holes themselves don't emit light, the only way we can see them is through their interactions with the space around them. Some reveal themselves by pulling in gas and dust, forming bright accretion disks of superheated material. Others bend and warp the light of distant stars through gravitational lensing, a phenomenon where the black hole acts like a cosmic magnifying glass. But if a black hole is truly isolated, moving through empty space without anything nearby to interact with, it could remain completely invisible. This means there could already be runaway supermassive black holes much closer than we realize. They could be lurking undetected in the vast emptiness between galaxies, slowly creeping toward us. If one were on a collision course with the Milky Way, we might not know until it was dangerously close. If we were to detect one, it would most likely be by noticing disruptions in the motion of other celestial objects. As it passed through space, its immense gravity would create disturbances in the orbits of stars and planets. If it moved through a distant galaxy, we might see stars being displaced in ways that don't make sense. If it came close to our own galaxy, we might notice entire star clusters behaving strangely, pulled by an unseen force. And if it were truly approaching our solar system, the first signs might be found in the distant reaches of the Oort cloud, the vast sphere of icy bodies that marks the outer edge of our Sun's gravitational influence. The Oort cloud is so far away that changes there would take thousands of years to be noticed from Earth. But if a rogue supermassive black hole were heading our way, its gravitational pull could start sending comets and asteroids inward long before the black hole itself arrived. We might see an increase in comet activity in the inner solar system, a sign that something massive was disturbing the balance of our cosmic neighborhood. And as it got closer, the effects would become impossible to ignore. At some point, the black hole's gravity would begin altering the orbits of the outer planets. Neptune, Uranus, and Saturn might start shifting unpredictably, their paths deviating from what centuries of observation have taught us to expect. Jupiter, the largest planet in the solar system, could become destabilized, its immense gravity no longer able to hold the delicate balance of planetary orbits together. The asteroid belt between Mars and Jupiter could be thrown into chaos, sending countless space rocks hurtling toward Earth. And then, as the black hole approached even closer, the inner planets, including Earth, would be at the mercy of forces beyond our control. The Sun's gravitational dominance, which has governed our solar system for billions of years, would begin to wane. Earth's orbit could stretch into an elongated shape, causing extreme temperature shifts that could render our planet uninhabitable. Or worse, we could be pulled directly toward the black hole, spiraling inward until the forces of gravity ripped our world apart. If humanity were still around at this point, what could we do? Could we escape? Even if we had the technology to build spacecraft capable of leaving the solar system, where would we go? Fleeing into deep space without a destination would be a death sentence. The distances between stars are so vast that even traveling at a fraction of the speed of light, it would take tens of thousands of years to reach another solar system. And there would be no guarantee that any other system we reached would be habitable. The grim truth is that if a supermassive black hole were on its way, we would have no chance of survival. Our civilization, our history, our entire existence would be wiped from the cosmos, leaving no trace that we were ever here. The black hole would continue its journey, indifferent to the destruction it had caused, drifting endlessly through the void. And yet, despite the horror of this possibility, there is something undeniably fascinating about it. The idea that these rogue titans are out there, roaming the universe unseen, reminds us of just how little control we have over the cosmos. We tend to think of space as vast and empty, but the reality is that it is filled with forces beyond our comprehension, forces that could change everything in an instant. The universe is not a stable, predictable place. It is a chaotic and violent expanse, where even the mightiest galaxies can be torn apart by unseen giants moving silently through the dark. So, is there a runaway supermassive black hole heading toward us right now? We don't know. But the fact that it's even possible should be enough to remind us that the universe is full of mysteries we have yet to uncover. And some of those mysteries might be coming straight for us. If a runaway supermassive black hole were on a collision course with our galaxy, how much time would we have? The answer depends on its speed and distance. The recently discovered runaway black hole in Able 2261, for example, is moving at millions of miles per hour. If something like that were heading our way from a distant galaxy, it could take millions of years to reach us. But in the grand scale of the universe, millions of years is nothing. The Milky Way has been around for over 13 billion years, and in that time, countless cosmic events have shaped its structure. It's entirely possible that supermassive black holes have passed near us before, perhaps even influencing the formation of star systems or triggering unknown cosmic phenomena. What's truly terrifying is that we might not even need a direct collision for disaster to strike. A passing supermassive black hole could cause devastation just by entering the outskirts of our galaxy. Its gravitational force would disrupt the delicate balance of interstellar space, sending entire star systems into chaos. The Milky Way's spiral arms, which have remained stable for billions of years, could be pulled out of alignment, distorting the shape of our galaxy beyond recognition. And if it got even closer, it could begin feeding on the stars themselves, swallowing entire solar systems as it carved a path through our galaxy. There is also the question of what happens if two runaway supermassive black holes collide. If one of these monsters were to encounter another of equal mass, the result would be one of the most violent events in the universe, a titanic merger of gravitational forces, releasing more energy than billions of stars combined. The collision would send out gravitational waves, ripples in space-time itself, strong enough to shake the very fabric of the cosmos. These waves have already been detected by observatories like LIGO, giving us glimpses into black hole mergers happening light years away. But if such an event were to occur closer to us, the gravitational disturbance could be felt across the Milky Way. The effects on space and time near such a merger would be extreme. The very structure of spacetime would warp in ways we can barely comprehend, bending and stretching like an elastic sheet caught in a violent storm. For any nearby stars and planets, the consequences would be catastrophic. If Earth were close enough to feel the pull of these merging giants, our planet would be ripped apart by tidal forces before we even had a chance to understand what was happening. But what if we got lucky? What if a runaway black hole passed by at just the right distance to spare us, but still close enough to alter our solar system? In that case, the most immediate effects would be gravitational disruptions. The Sun's mass would no longer be the dominant force governing our orbits, and that would throw everything into chaos. Planets might be flung into space, becoming rogue planets drifting through the void. Others might be drawn toward the black hole, disappearing into the abyss. Even if Earth remained in the habitable zone, our seasons, tides, and entire climate system would be thrown into unpredictability. Humanity would be left struggling to survive in a world where the fundamental laws of nature had changed overnight. But what if we weren't lucky? What if the black hole was coming directly for us? As it approached, the first thing we would notice is the eerie distortion of the night sky. Light from distant stars would begin bending in strange ways, creating a phenomenon known as gravitational lensing. Stars would appear stretched, warped into rings and arcs that defied all logic. Then, as it got even closer, the black hole's event horizon, the point of no return, would start swallowing everything in its path. The sheer destruction would be beyond comprehension. Entire planets, moons, and asteroid fields would vanish as they crossed the threshold, falling into the black hole's grasp with no chance of escape. The matter consumed by the black hole would be heated to billions of degrees, creating a blinding accretion disk that would outshine entire galaxies. If Earth were caught in this process, it would be obliterated long before reaching the event horizon, torn apart by tidal forces so extreme that even atoms themselves would be stretched into unrecognizable forms. And what would happen if somehow, against all odds, a spacecraft carrying the last remnants of humanity managed to escape before the destruction? Where would they go? Drifting through space with no home to return to, they would face an uncertain fate, searching for a new world in a universe that had just proven how unforgiving it can be. The more we learn about runaway supermassive black holes, the more we realize how fragile our place in the universe truly is. We tend to think of our solar system as a stable, unchanging environment, but the truth is, it exists in a constant state of cosmic uncertainty. There are forces in the universe beyond our control, forces so powerful that they can erase entire civilizations without a trace. And the scariest part? We might never see it coming. A runaway supermassive black hole moving through the cosmos isn't just a theoretical possibility, it's an active, ongoing event that astronomers are racing to understand. The discovery of these wandering giants has changed our understanding of galaxy formation, black hole mergers, and even the fundamental structure of the universe. But the real question is, how common are they? And could there be one lurking closer than we think? Scientists estimate that there could be hundreds, if not thousands, of rogue supermassive black holes drifting through intergalactic space. Most of them were likely ejected from their home galaxies due to violent mergers, slingshot gravitational effects, or interactions with unseen cosmic forces. Unlike stars, which shine brightly and give away their position, a black hole is nearly impossible to detect unless it's actively feeding on matter. This means there could be one moving through the dark void of space right now, invisible to our telescopes, only revealing itself if it passes close enough to distort the light of background stars. The biggest problem with detecting a runaway black hole is that space is unimaginably vast, and black holes don't emit light. Most of the time, they only become visible when they interact with surrounding matter, pulling in gas, dust, and even entire stars. When this happens, they create some of the brightest objects in the universe, quasars. But a truly isolated runaway black hole, one that isn't consuming matter, would be almost impossible to see. This means that until we refine our detection methods, we could be completely unaware of the rogue black holes moving through intergalactic space. So, what happens if one is headed in our direction? The good news is that the chances of a direct collision are incredibly low. Space is so vast that even with thousands of rogue black holes out there, the distances between galaxies and star systems make a direct hit unlikely. However, even a near miss could have catastrophic consequences. If a runaway black hole were to pass within a few light years of our solar system, its gravitational pull could be strong enough to disrupt the Oort cloud, a vast region of icy bodies surrounding our solar system. This disturbance could send a wave of comets and asteroids hurtling inward, increasing the chances of a planet-killing impact on Earth. If the black hole came even closer, the gravitational effects would become even more severe. It could destabilize the orbits of planets, causing some to spiral into the Sun while flinging others into deep space. The Sun itself, though incredibly massive, could experience slight shifts in its position, affecting the delicate balance that keeps our solar system in order. And if Earth's orbit were to change, even slightly, it could mean the difference between a stable climate and an extinction-level event. But perhaps the most terrifying scenario is one where a runaway supermassive black hole actually enters our galaxy and begins feeding. This is where things get truly apocalyptic. As the black hole moves through the Milky Way, it would begin consuming stars, pulling them in with its immense gravity. The matter being devoured would heat up, forming an accretion disk that could release bursts of high-energy radiation. This radiation, if powerful enough, could strip away the atmospheres of nearby planets, rendering them uninhabitable. Even from a distance, this kind of cosmic activity could have profound effects on the galaxy, possibly triggering chain reactions of destruction. There's another unsettling possibility. What if a runaway supermassive black hole has already passed through our galaxy in the past? Given the age of the Milky Way, it's entirely possible that such an event has occurred before. It could explain some of the unusual movements of certain star clusters or even be responsible for past mass extinctions on Earth. If a black hole had disturbed our solar system millions of years ago, we would have no way of knowing, except by studying the long-term effects it may have left behind. Astronomers are now developing new methods to detect these elusive wanderers. One approach is looking for their gravitational influence on surrounding stars. Even if a black hole itself is invisible, its presence can be inferred by the way it distorts and moves nearby celestial objects. Another method involves searching for subtle distortions in the cosmic microwave background, the afterglow of the Big Bang. If a rogue black hole has been moving through space for billions of years, it could have left behind a detectable imprint on the universe itself. But the ultimate question remains, will we ever be able to stop one? If a supermassive black hole were on a collision course with our galaxy, could we do anything about it? The unfortunate truth is that, with our current technology, the answer is no. A black hole is not a physical object that can be pushed or destroyed. It's a warping of space and time itself. There is no force in the universe strong enough to stop it. The only thing we could do is observe, prepare, and if possible, escape to another star system. And that raises an even more unsettling thought. Has this already happened to other civilizations? If runaway supermassive black holes are common, then it's likely that entire galaxies, perhaps even alien civilizations, have already been wiped out by them. Could there be advanced civilizations out there who saw their doom approaching and tried to escape, only to vanish into the void? Could the silence of the universe, the eerie absence of detectable alien life, be because of these cosmic monsters? If we ever do detect a runaway supermassive black hole heading our way, it will be a race against time. We may have thousands or even millions of years to act, but in the grand scheme of things, that's not much time at all. The universe is filled with dangers beyond our comprehension, and a rogue black hole may be the most terrifying of them all. It is a reminder that, no matter how advanced we become, we are still at the mercy of forces far greater than ourselves. And in the end, we may never see it coming. The most unsettling thing about a runaway supermassive black hole is how silent its destruction would be. There wouldn't be any warning signs in the traditional sense, no bright explosion, no fiery impact. Instead, space itself would warp and bend as the black hole approached, subtly distorting the orbits of planets and stars long before we even realized what was happening. This makes it one of the most terrifying cosmic threats, because by the time we detect it with certainty, it could already be too late to do anything about it. The only way we would know it's coming is by noticing the unexplained behavior of celestial objects. Maybe a distant star suddenly veers off course. Maybe a nearby pulsar starts exhibiting strange timing anomalies. These small hints could be the only clues we get before a rogue black hole comes dangerously close. And if one were truly on a collision course with our galaxy, what would happen to the Milky Way itself? The first thing to consider is its gravitational impact. A supermassive black hole is millions, or even billions, of times the mass of our Sun. Even if it were moving at incredible speeds, the sheer force it exerts on surrounding objects would be enough to wreak havoc. Entire star systems could be flung into intergalactic space, orphaning planets and leaving them to drift in eternal darkness. Some stars might get pulled directly into the black hole, consumed in an inferno of radiation as they spiral into oblivion. Others might be ejected from their host galaxies entirely, becoming rogue stars wandering the void between galaxies, never to return. This isn't just a hypothetical scenario. Astronomers have already observed evidence of stars being ejected from galaxies at extreme speeds. Some of these hypervelocity stars are thought to be the result of interactions with supermassive black holes. When a trio of objects interacts gravitationally, one of them can be violently expelled. This means that if a runaway black hole were to enter our galaxy, we might see an uptick in these hypervelocity stars, a celestial warning sign that something massive and unseen is moving through our region of space. But let's take this even further. What if a runaway supermassive black hole actually entered the core of the Milky Way, where our own central black hole, Sagittarius A*, resides? This is where things get truly apocalyptic. If two supermassive black holes were to collide, the energy released would be beyond anything humanity has ever imagined. The collision would unleash gravitational waves so powerful that they would ripple through the fabric of space-time itself. These waves would distort reality on a cosmic scale, potentially affecting entire star systems thousands of light-years away. The merger would also generate an immense outburst of energy, possibly forming a quasar, a beacon so bright that it could be seen from other galaxies. But the aftermath of such a collision would be even more chaotic. The newly formed black hole, now larger and more powerful than ever, would consume everything around it with an insatiable hunger. Gas clouds, stars, and even smaller black holes would be drawn into its grasp, fueling an era of destruction that could last millions of years. The Milky Way, as we know it, could be permanently altered. Our galaxy's structure might change, its spiral arms reshaped, and its stellar populations disrupted. Entire regions of space could be sterilized by intense radiation, making them uninhabitable for any life that might exist there. But what if a runaway supermassive black hole didn't just pass through our galaxy? What if one came close to our solar system? The first signs would be subtle but devastating. The outermost objects in our solar system, like the Oort cloud and the Kuiper belt, would feel the gravitational effects first. This means a sudden influx of comets and asteroids being thrown into the inner solar system, dramatically increasing the risk of impact events. Over time, the black hole's influence would grow stronger, distorting the orbits of planets, causing unpredictable climate shifts, and potentially pulling some planets entirely out of the solar system. The worst-case scenario would be Earth falling into the black hole's event horizon. If that were to happen, there would be no escape. The moment our planet crossed that invisible boundary, time itself would slow to a crawl from an outside observer's perspective. But for anyone unfortunate enough to be on Earth, the experience would be surreal and terrifying. Spaghettification, the stretching of matter due to extreme gravitational forces, would begin, pulling everything apart at the atomic level. Within moments, Earth would be reduced to a stream of particles spiraling toward the singularity, lost forever in the abyss. This leads to a mind-bending question: what happens to anything that falls into a black hole? According to general relativity, all information about an object that crosses the event horizon is lost. But quantum mechanics suggests that information can't truly be destroyed. This paradox, known as the black hole information paradox, remains one of the biggest mysteries in physics. If a runaway black hole consumed an entire planet, does that planet's information still exist in some form? Could it be encoded in the black hole's event horizon, or is it lost to the universe forever? The nature of black holes is so complex that even the brightest minds in science struggle to fully understand them. Some theories suggest that black holes might not be the ultimate endpoints of matter. Instead, they could be gateways to entirely new universes, with every black hole potentially leading to a separate reality beyond our own. If that's true, then a runaway black hole might not just be a destroyer. It could be a portal to something beyond our comprehension. But let's bring things back to reality. What can we do to protect ourselves from such a threat? Right now, not much. Our best defense is early detection. If we can identify a rogue black hole long before it reaches us, we might have a chance to develop new technologies that could alter our trajectory, or even move our civilization to another star system. This is why projects like the Vera C, Rubin Observatory, the James Webb Space Telescope, and future gravitational wave detectors are so important. They might not just help us understand the cosmos, they could be the key to our survival. The more we learn about runaway supermassive black holes, the more we realize how little control we truly have over the universe. They are silent predators, drifting through space, swallowing everything in their path. And yet, their existence also forces us to confront the vastness of the cosmos and our place within it. We are tiny, fragile beings living on a small rock, orbiting an average star, in a galaxy that is just one of trillions. And out there, somewhere in the void, a runaway black hole may already be moving in our direction. The only question is, will we see it before it's too late? If a runaway supermassive black hole were truly on a collision course with our galaxy, it wouldn't just be an astronomical event, it would be an existential crisis. The sheer gravitational force of such an object would bend the fabric of space itself, pulling everything in its wake into chaos. Galaxies are delicate structures, held together by a precise balance of gravity and motion. But if a supermassive black hole were to intrude upon this delicate balance, entire star systems could be shredded apart like paper in a storm. Stars that have existed peacefully for billions of years would suddenly find themselves either hurled into the void or dragged into the abyss. The thing about black holes is that they don't emit light on their own. They are invisible voids in space, detectable only by the effects they have on their surroundings. So, if a runaway supermassive black hole were approaching, we wouldn't see it coming. Instead, we would notice anomalies. Planets would start behaving erratically. Moons would shift unpredictably in their orbits. Even our sun might wobble in ways that defy explanation. Scientists would study these anomalies, trying to piece together what was happening, until they finally realized the terrifying truth: something massive, something unseen, was approaching. Imagine the panic that would unfold across the world. The moment scientists confirmed the existence of a rogue supermassive black hole heading toward the Milky Way, humanity would be faced with an impossible question: what can we do? Right now, our understanding of space travel is incredibly limited. We struggle just to get to Mars. Leaving our solar system is beyond our current technological capabilities. And yet, if a supermassive black hole was inbound, the only real way to survive would be to escape, to find a way to leave the Milky Way before it's too late. But how? Where would we go? Would we even have enough time to develop the technology needed to relocate an entire civilization? The more you think about it, the more you realize just how vulnerable we truly are. Earth feels solid. Our solar system feels stable. But in the grand scheme of the universe, we are at the mercy of forces far beyond our control. A black hole moving at millions of miles per hour is not something we can negotiate with. It doesn't care about our civilizations, our history, or our future. It simply moves forward, consuming everything in its path. But let's assume, for a moment, that we were lucky. Let's say the runaway black hole didn't collide directly with our solar system but instead passed by at a safe enough distance that it didn't pull us in. That doesn't mean we'd be safe. Even from a distance, the effects of a black hole's gravitational pull could wreak havoc on the structure of the Milky Way. The orbits of countless stars could be disrupted, flinging them into new and unpredictable paths. Some could be sent hurtling into intergalactic space, where they would wander alone for eternity. Others might be pulled into dense clusters, sparking new waves of star formation or even triggering violent supernovae. And then there's the question of dark matter. We still don't fully understand what dark matter is, but we know that it makes up the majority of the universe's mass. If a runaway supermassive black hole were to pass through a region of dense dark matter, could it trigger some kind of chain reaction? Could it distort the unseen web that holds galaxies together, causing ripples that would be felt across the entire universe? There's also the possibility that a runaway black hole isn't truly alone. What if it came from a galaxy that was once part of a larger system? What if, instead of a single runaway black hole, we're actually looking at an entire cluster of black holes moving together, unseen and unstoppable? If even one supermassive black hole can reshape a galaxy, what could an entire rogue cluster do? Could it become the ultimate cosmic predator, devouring one galaxy after another in an endless rampage through the universe? The more we study black holes, the more questions we have. Even though we have detected gravitational waves from black hole mergers, we still don't fully understand what happens in the final moments before two supermassive black holes collide. We don't know if these mergers could trigger exotic physics beyond what we currently understand. Some theories suggest that when two black holes merge, they could create something even stranger, an object so dense that it defies the known laws of physics. Could runaway black holes be the remnants of such collisions? Could they be carrying unknown forces with them as they move through space? And what if a runaway black hole wasn't truly an accident? What if, in some distant part of the universe, an advanced civilization once existed that had the ability to manipulate black holes? Could they have used them as weapons, as power sources, or even as portals to other dimensions? And if so, what happened to them? Did they unleash something they couldn't control? Did they accidentally send a supermassive black hole careening into the cosmos, dooming countless galaxies in the process? Right now, we have no answers, only theories. But one thing is certain, somewhere out there, in the vast darkness of space, a runaway supermassive black hole is moving. It could be billions of light years away, or it could be much closer than we think. And one day, if the universe is truly as chaotic as we suspect, it could come for us. If a runaway supermassive black hole were truly on a trajectory toward our galaxy, we wouldn't have the luxury of waiting centuries or millennia to react. The problem with black holes, especially rogue ones, is that they don't announce their presence in ways we can easily detect. If a black hole of this magnitude were moving toward us, it wouldn't shine like a star or be visible like a planet. Instead, it would remain completely invisible, detectable only by the destruction it leaves behind. And by the time we notice that destruction, it could already be too late. Scientists rely on gravitational lensing and the distortions black holes cause to nearby objects to track them. But the universe is vast, and even with our most advanced telescopes, we have only a fraction of the picture. There could be rogue supermassive black holes moving through intergalactic space that we have yet to discover. Some may have originated from violent galactic mergers billions of years ago. Others might be remnants of collisions so ancient that the light from those events has long since faded. The unsettling part is that we already have evidence of at least one runaway supermassive black hole moving at extraordinary speeds. A discovery made using the Hubble Space Telescope found a supermassive black hole that appeared to be fleeing from its host galaxy at over 3 million miles per hour. To put that into perspective, if this black hole were traveling through our solar system, it could cross the entire distance from the Sun to Pluto in just a few days. That's how fast we're talking. But the real mystery is, what gave it such an incredible speed? The leading theory suggests that this runaway black hole was ejected from its galaxy due to the gravitational effects of a three-body interaction. Essentially, when three supermassive black holes interact, usually after galaxies merge, their gravitational forces can create an unstable system. One of the black holes can then be slingshot out of the galaxy at extreme speeds, while the remaining two settle into a stable orbit. This event, known as a gravitational recoil, can send a supermassive black hole flying across space, completely untethered. But there's an even more bizarre possibility. What if some runaway black holes were never part of a galaxy at all? What if they formed in the early universe in ways we don't yet understand? We still don't fully know how supermassive black holes formed to begin with. Are they created from the collapse of massive stars over time? Or did they form directly from massive clouds of primordial gas in the early universe? If the latter is true, then it's possible that some black holes have been moving through space as nomads since the very beginning, never belonging to any galaxy, never being held in orbit around anything. And here's where things get even more unnerving. If rogue supermassive black holes exist, then they are essentially the largest, most powerful wandering objects in the universe. Most of space is empty, so the chances of one of these rogue giants colliding directly with another galaxy are relatively low. But relatively low doesn't mean impossible. If a rogue black hole were to enter a galaxy, the effects would be catastrophic. First, it would begin distorting the orbits of stars in its vicinity. The closer it got, the more extreme these distortions would become. Stars that had been peacefully orbiting the galactic core for billions of years could suddenly be thrown into chaos, some flung into deep space, others dragged into collision courses with neighboring stars. Entire planetary systems could be thrown into disarray. If the rogue black hole passed through the Milky Way, it could cause unpredictable shifts in our own solar system. Even if Earth wasn't directly affected, the long-term gravitational disruptions could be enough to alter our planet's orbit in subtle ways that could have devastating consequences over thousands or millions of years. And then there's the accretion disk. When black holes consume matter, they form a swirling disk of gas and dust around them, heating it to extreme temperatures. This process releases enormous amounts of radiation, sometimes making black holes among the brightest objects in the universe. If a rogue supermassive black hole entered our galaxy and began consuming material, it could light up like a second quasar. The radiation from such an event could be lethal if it were close enough. It could strip away atmospheres, sterilize planets, and make entire regions of space uninhabitable. But what if a runaway supermassive black hole were already much closer than we think? What if one were lurking in the dark regions of intergalactic space, heading toward us at millions of miles per hour? The terrifying reality is that we wouldn't see it coming until it was practically on our doorstep. Unlike stars, which shine brightly and can be detected from billions of light years away, black holes don't emit their own light. They are, by definition, the darkest objects in existence. We could have a rogue black hole heading toward us right now, and unless it began interacting with other matter in a noticeable way, we wouldn't know it was there. And then there's the question of how many of these rogue supermassive black holes exist. Right now, we've only detected a handful of possible candidates. But space is vast, and our ability to detect these objects is still extremely limited. If even one rogue black hole is out there, it stands to reason that there could be many more. Perhaps hundreds. Perhaps thousands. Some may be moving away from us, but others could be closing in. The scariest part? There is nothing we can do to stop one. A black hole is not like an asteroid. You can't nuke it, you can't deflect it, and you can't land on it to drill a hole in it like some Hollywood movie. A black hole is a force of nature, an unstoppable titan of destruction. If one were headed for us, we wouldn't be able to change its course. The only real question would be whether humanity had enough time to escape, and right now, we don't even have the technology to leave our own solar system. The only hope would be detection, finding a rogue supermassive black hole long before it got anywhere near our galaxy. But even then, what would we do? Would humanity unite to build the technology needed to escape? Or would we simply accept our fate, watching as an unstoppable force erased our very existence from the cosmos? The universe is a terrifying place. We like to think of space as peaceful and silent, but in reality, it is filled with destruction. Stars explode, galaxies collide, and entire civilizations could be wiped out without anyone ever knowing they existed. Runaway supermassive black holes are just another reminder that we are not in control. We are tiny, fragile creatures living on a small rock in an incomprehensibly vast and violent cosmos. And somewhere out there, in the dark void between galaxies, something enormous may be moving toward us right now, silent, unseen, unstoppable. The unsettling truth about runaway supermassive black holes is that they are almost impossible to track, and we may never have enough warning before one enters our cosmic neighborhood. Unlike planets, which reflect light, or stars, which shine brightly, black holes are the ultimate voids of the universe, absorbing all light and matter that crosses their event horizon. The only way we detect them is through their effects on surrounding space, such as bending light from distant objects, or disrupting the orbits of nearby stars. But what happens if a runaway supermassive black hole is traveling through a region of space with very little matter around it? It could move undetected for millions, if not billions, of years. Some scientists suspect that many more of these rogue black holes exist than we realize, hidden within the vast stretches of intergalactic space where we don't have enough observational data to confirm their presence. If a black hole is not actively consuming material, it remains virtually invisible. No glowing accretion disk, no radiation, no obvious signs of destruction, just a massive gravitational force moving through the cosmos in silence. This is what makes runaway supermassive black holes so terrifying. They don't announce their arrival. If one were approaching the Milky Way, the first sign might not even be the black hole itself. Instead, we might notice strange movements in distant star clusters, as their orbits become slightly distorted by an unseen force. Over time, these distortions would become more extreme, as stars get pulled out of their expected paths. Eventually, some would be flung into deep space, while others would spiral inward, possibly forming a chaotic, elongated disk of doomed stars. By the time we realized what was causing this disturbance, the black hole could already be too close to do anything about it. Some scientists have suggested that the Milky Way may have already encountered rogue black holes in the past without us even realizing it. The chaotic motion of some star systems could be explained by an ancient collision with a runaway black hole that passed through our galaxy millions of years ago, leaving behind disrupted star clusters as evidence of its journey. If such an event happened once, it could certainly happen again. But what happens if a runaway supermassive black hole enters our galaxy and heads directly toward the solar system? The consequences would be catastrophic long before it even got close. The gravitational influence of such a massive object would throw the orbits of countless stars into chaos, leading to violent chain reactions that could disrupt entire planetary systems. The Sun itself could be affected, either by being subtly nudged off course or by having its own gravitational stability altered in ways that could change the conditions of our solar system forever. If a runaway supermassive black hole came close enough, it could rip entire planets apart. The gravitational tidal forces near a black hole are so extreme that anything that comes too close is stretched and torn apart, a process known as spaghettification. Even massive gas giants like Jupiter wouldn't stand a chance if they crossed the event horizon. The closer the black hole got to our solar system, the worse things would become. The Earth itself could be pulled from its orbit, either sent hurtling into deep space or dragged into the inferno of the Sun. Even if Earth somehow survived the gravitational chaos, the radiation from an active accretion disk would be enough to strip away our atmosphere, making the planet uninhabitable. And here's the truly terrifying part: we have no way of stopping it. Humanity has spent centuries worrying about asteroid impacts, gamma-ray bursts, and supernovae, but a rogue supermassive black hole is on an entirely different level. There is no defense, no warning system, no escape plan. If one were heading toward us, the best we could do is watch, and hope it changes course before it's too late. But what if we've already seen evidence of a rogue black hole on its way? Some astronomers have suggested that unexplained gravitational anomalies in certain regions of space could be caused by unseen black holes moving through intergalactic space. While none have been definitively confirmed, the possibility remains that one of these anomalies could be an incoming runaway black hole. If this is the case, then our only hope would be to detect it soon enough to develop a plan. Though whether that plan would involve escaping Earth or simply preparing for the inevitable is another question entirely. The unsettling reality is that we are at the mercy of the cosmos. Black holes are some of the most mysterious and dangerous objects in existence, and a runaway supermassive black hole is essentially the ultimate cosmic predator, moving through space with nothing to stop it. For now, all we can do is continue scanning the skies, hoping that if one is out there, it isn't heading straight for us. If a runaway supermassive black hole were on a collision course with our galaxy, how much time would we have before disaster struck? The unsettling answer is that we likely wouldn't know until it was far too late. Supermassive black holes travel at speeds of millions of miles per hour, meaning that even if one were detected at the edge of the observable universe, it could reach us much sooner than we might expect. And if it's already lurking somewhere in intergalactic space, silently making its way toward us, there's no telling how close it might already be. But how did these runaway black holes come to exist in the first place? The leading theory involves galaxy mergers. When two galaxies collide, their supermassive black holes don't immediately merge. Instead, they orbit each other in a chaotic dance that can last millions of years. During this process, gravitational forces interact with the surrounding stars and gas, creating intense disturbances that can eject one of the black holes at incredible speeds. In some cases, the newly formed black hole pair will merge, but in others, one of them gets slingshot out of the galaxy entirely. Once that happens, it's a runaway. What's fascinating is that these ejections can be so powerful that the black hole never slows down. Unlike stars or planets, which can be caught in gravitational wells and pulled back into orbit, a supermassive black hole has so much momentum that it just keeps going. Forever. There is nothing in the universe that can stop it. It will drift through intergalactic space, completely untethered, until it either collides with another galaxy or simply continues on its path for eternity. The real mystery is how many of these objects exist. We know that galaxy mergers are common in the universe. Our own Milky Way is on a collision course with the Andromeda Galaxy, and when that happens, our central black hole will interact with Andromeda's, potentially creating a new runaway black hole. But that's just one example. With billions of galaxies in the universe, each with its own supermassive black hole, how often do these objects get ejected? Some astronomers believe there could be millions of rogue supermassive black holes drifting through intergalactic space at this very moment. Others think they might be even more common than that. The problem is that they are incredibly difficult to detect. Unlike ordinary black holes, which sometimes reveal their presence by pulling in gas and dust, runaway supermassive black holes might travel through areas of space with little to no material around them. That means no accretion disk, no X-ray emissions, no visible light, nothing that would make them stand out. The only way we might detect one is by observing the gravitational lensing effect it has on background galaxies, but even that is rare. These objects are, quite literally, invisible threats lurking in the void. One of the most recent discoveries suggesting the existence of a runaway supermassive black hole was a strange streak of stars detected by the Hubble Space Telescope. This streak appeared to be a trail left behind by something incredibly massive moving through space at high speed. The best explanation? A supermassive black hole that had been ejected from its host galaxy, pulling stars along with it as it traveled. If true, this would be direct evidence that runaway black holes are not just theoretical. They are real, and they are out there. But the scariest question remains, could one be headed toward us? Statistically, the chances are low, but low doesn't mean impossible. The universe is vast, but so is time. Even if there isn't one close to us now, that doesn't mean one couldn't arrive in the distant future. And if it did, there would be no stopping it. Our best hope would be to detect it early enough to understand how much time we have left. The worst-case scenario would be discovering a runaway supermassive black hole only after it has already begun to affect our galaxy. The moment we notice unexplained disruptions in the orbits of distant stars, it could already be too late. If a rogue black hole were to enter the Milky Way, it wouldn't just pass through quietly. Its gravity would wreak havoc on everything in its path, destabilizing planetary systems and altering the trajectories of entire star clusters. It could tear apart nebulae, disrupt the balance of our galactic core, and potentially even send stars hurtling toward us. If such an object ever came close to our solar system, we would face an existential crisis unlike anything humanity has ever imagined. The gravitational pull of a supermassive black hole would distort space-time itself, stretching and warping everything in its vicinity. If Earth were to be drawn into its influence, we would either be thrown into deep space, away from the sun and into eternal darkness, or we would be dragged closer, eventually consumed by the black hole itself. Either fate would mean the end of all life as we know it. The only real comfort is that space is unimaginably vast, and the odds of a runaway black hole reaching us anytime soon are slim. But that doesn't mean we shouldn't keep looking. If we can detect these objects before they get too close, we might at least have time to prepare, if not to stop them, then at least to understand our fate. The universe is full of mysteries, and some of them are more terrifying than we ever imagined. If a runaway supermassive black hole were on its way toward us, how early would we be able to detect it? That's a question that keeps astronomers up at night. Black holes, by their very nature, don't emit light, making them some of the most elusive objects in the universe. Even a black hole with the mass of millions, or even billions, of suns would be effectively invisible against the backdrop of space. Our best shot at detecting one would come from observing its effects on the objects around it, but that might not happen until it's already dangerously close. One of the first signs of an incoming supermassive black hole would be subtle shifts in the orbits of stars in our galaxy. Every star in the Milky Way follows a predictable path around the galactic center, influenced by the gravitational pull of the billions of other stars and dark matter in the region. But if a rogue black hole entered our galaxy, it would start to exert its own gravitational influence, slowly distorting these orbits. Initially, these changes would be imperceptible, but as the black hole came closer, the disruptions would grow more extreme. Stars that had stable orbits for billions of years would begin drifting in unexpected directions, some accelerating toward the black hole while others were flung outward. Another key indicator would be the bending of light from distant galaxies. This phenomenon, known as gravitational lensing, occurs when a massive object warps the space around it, causing light to curve as it passes by. If a runaway supermassive black hole were moving through intergalactic space, astronomers might detect sudden, unexplained distortions in the shapes of background galaxies. However, this method has a major drawback. It only works if the black hole passes directly between us and another galaxy. If it's coming from an angle where no bright objects sit behind it, we might not see anything at all. One terrifying possibility is that a rogue supermassive black hole could be traveling toward us from a region of space where we have limited visibility. There are vast stretches of the cosmos filled with interstellar dust and gas, effectively blocking our view of what lies beyond. If a black hole were moving toward us from behind one of these cosmic clouds, we wouldn't see it until it was far too close to do anything about it. And if it were moving at a significant fraction of the speed of light, we could have only decades, or even just years, before it reached our solar system. The gravitational pull of a supermassive black hole wouldn't just affect distant stars. As it entered the outer reaches of the Milky Way, it would begin pulling on entire star systems, destabilizing planets and potentially sending rogue planets hurtling through space. If our solar system were caught in its influence, we might see changes in the orbits of planets long before the black hole itself became visible. Jupiter, for example, could shift slightly in its orbit, a change that would have cascading effects on the gravitational balance of our entire solar system. Even a tiny deviation in the path of a planet could spell disaster for Earth, altering the climate in ways we couldn't predict. As the black hole moved closer, its effects would become more severe. The immense gravitational forces would begin drawing in gas and dust, forming an accretion disk that could become incredibly hot and luminous. This would be our first direct visual confirmation, a bright, glowing ring of material spiraling into an unseen abyss. At this point, we would know for certain that a runaway supermassive black hole was inbound, but by then, it might already be too late. What happens next would depend on the trajectory of the black hole. If it were on a direct collision course with our solar system, there would be nothing we could do to stop it. The closer it got, the more extreme its gravitational influence would become, distorting space-time itself. The moon's orbit around Earth would shift, potentially triggering massive tidal forces that could cause catastrophic earthquakes and tsunamis. Meanwhile, Earth's own orbit around the Sun could become unstable. If we were pulled even slightly closer to the Sun, temperatures would rise dramatically, turning our planet into an uninhabitable wasteland. If we were pushed outward, we could be sent into a deep freeze, plunging into a new ice age that would wipe out most life on Earth. In the absolute worst-case scenario, Earth would be drawn directly into the black hole itself. As we approached the event horizon, the point of no return, time would begin to stretch, slowing down relative to the outside universe. To an outside observer, Earth would appear to freeze in place, forever suspended just outside the black hole's edge. But from our perspective, time would continue as normal, and as we crossed the event horizon, there would be no turning back. The fabric of space-time would stretch infinitely, tearing atoms apart in a process known as spaghettification. Everything we have ever known, our history, our civilizations, our entire existence, would be erased in an instant, consumed by the black hole with no trace left behind. But what if the black hole didn't hit us directly? What if it merely passed through our galaxy, missing our solar system by a safe margin? Even in that scenario, the damage could be catastrophic. The Milky Way is a delicate structure, held together by the gravitational pull of its central supermassive black hole and the billions of stars orbiting it. If a rogue black hole were to enter our galaxy, it could throw everything into chaos, distorting orbits, triggering violent star formation, and even altering the structure of the galactic core. Entire star systems could be ejected into intergalactic space, forever lost in the void between galaxies. And what about our own supermassive black hole, Sagittarius A*? Could a collision between it and a runaway black hole occur? Theoretically, yes. If a rogue black hole of comparable size were to enter our galaxy and head toward the center, the two could eventually meet in a cataclysmic merger. Such an event would release an unfathomable amount of energy, sending gravitational waves rippling across the universe. While the merger itself wouldn't pose a direct threat to Earth, the aftermath could be unpredictable. The gravitational shockwaves could destabilize orbits throughout the galaxy, while the newly formed black hole could be ejected, becoming yet another runaway, drifting through the cosmos in search of its next victim. The true horror of runaway supermassive black holes isn't just that they exist, but that we have no way of stopping them. Unlike other cosmic threats, such as asteroid impacts or supernovae, which we might one day be able to mitigate with advanced technology, a black hole is an unstoppable force. There is no deflecting it, no shielding ourselves from its effects. Our only hope is to detect them early enough to understand what's coming, and to accept our fate if one ever heads our way. Despite this, most of the universe will likely never encounter one of these rogue giants. Space is vast beyond comprehension, and even though black holes are terrifying, they are still rare on a cosmic scale. But that doesn't mean we shouldn't be watching. The more we learn about runaway black holes, the better we can prepare for the possibility that one day, against all odds, one might come for us. And if that day ever comes, we will have no choice but to face the greatest force the universe has ever known. A runaway supermassive black hole tearing through the cosmos is a haunting reality, one that reminds us of how little control we have over the forces of the universe. These celestial monsters, formed in the hearts of galaxies, are supposed to remain anchored at their centers, bound by the collective gravity of billions of stars. Yet, in rare and violent events, they can be launched into the cosmic void, moving at millions of miles per hour with no destination, just an endless journey through space. One of the biggest questions surrounding these rogue giants is what happens to everything in their path. A runaway supermassive black hole doesn't just wander harmlessly, it disturbs everything it comes near. Galaxies are fragile ecosystems, delicately balanced by gravity. If one of these black holes were to pass through a galaxy, even if it didn't collide with a star system directly, the effects could be devastating. Its immense gravity could stretch and distort entire spiral arms, twisting them in unnatural ways. It could destabilize planetary orbits from light years away, flinging some planets into deep space while pulling others toward their host stars, creating hellish worlds that are either scorched or frozen. Even more terrifying is what happens when a runaway black hole captures material as it moves. Black holes don't actively consume everything around them. They have to come close enough to objects to exert a strong gravitational influence. But when they do, they can start forming accretion disks, glowing halos of superheated gas and dust spiraling into the abyss. This means that a rogue black hole could become visible, not because of the black hole itself, but because of the brilliant inferno of matter falling into it. If a runaway supermassive black hole entered a dense region of space, it could ignite a luminous quasar, a beacon so bright it would outshine entire galaxies. This process doesn't happen instantly. It takes millions of years for material to fall into a black hole, for the heat and radiation to build to extreme levels. But once it does, the energy output is staggering. A single quasar powered by a black hole can emit more light than the combined glow of hundreds of billions of stars. If a rogue black hole were to ignite such a quasar while moving through intergalactic space, it would be one of the most awe-inspiring yet ominous sights imaginable, a glowing wound in the fabric of the universe, marking the path of destruction left behind. If such a quasar were nearby, the consequences could be even worse. The radiation from a quasar can sterilize entire regions of space. Planets that once had the potential for life could be bathed in high-energy emissions, stripping away their atmospheres and turning them into barren husks. The thought of a runaway supermassive black hole, not just moving silently through the universe, but actively consuming and destroying everything in its wake, is a nightmare scenario. It means that even if one doesn't collide with our galaxy directly, its passage nearby could be enough to cause irreversible damage. But what if we could detect one early enough? Would there be anything we could do? The unfortunate answer is no. Black holes are the most extreme objects in the universe, bending space and time itself. There is no force, no explosion, no amount of energy we could create that would be capable of stopping one. Unlike an asteroid, which could theoretically be deflected, or a supernova, which is a predictable event, a rogue black hole is an unstoppable force. If one were coming toward us, we wouldn't be able to change its course, and our only option would be to try to escape. But escape to where? Even if humanity had the technology to travel between star systems, which we currently don't, there's no guarantee that fleeing would save us. A supermassive black hole moves at such high speeds that it could cross entire interstellar distances faster than any spacecraft we could design. By the time we even detected it, it could already be too late to leave. Even more concerning is the fact that we might not detect one at all. Some black holes travel through regions of space that are largely empty, avoiding large clouds of gas and dust. If a black hole were moving through one of these regions, it would be nearly invisible until it was dangerously close. The only clue we would have might be the gravitational effects it exerts on nearby stars and planets. But by the time we notice those effects, it might already be inside our galaxy. There's also the possibility that we have already encountered a runaway supermassive black hole in the past, but we simply didn't know what we were looking at. Some galaxies appear to have unusual distortions, as if they have been stretched or pulled by an unseen force. Astronomers have suggested that these distortions might be caused by black holes passing through them, altering their structures in ways we don't yet fully understand. If that's the case, it raises a chilling question: how many of these rogue giants are out there, moving silently through the darkness, waiting for their next encounter? Perhaps even more mind-bending is the idea that our own galaxy could have lost a supermassive black hole at some point in the past. While Sagittarius A* sits at the center of the Milky Way, astronomers have long speculated about whether other black holes could exist within our galaxy, remnants of ancient mergers with smaller galaxies. If one of those black holes were ejected millions of years ago, it could still be drifting through the Milky Way undetected. It might even be closer than we realize, hidden in the vastness of space, waiting for the moment when it finally makes itself known. This brings us to one of the most profound mysteries of all. What happens to a runaway supermassive black hole after billions of years? Does it eventually slow down, captured by another galaxy's gravity? Does it continue traveling forever, a ghostly remnant of a lost civilization? Or could it end up in the vast emptiness between galaxies, where it will never encounter another star again? We don't yet have answers to these questions, but one thing is certain: runaway supermassive black holes are out there. They are real, they are moving, and they are beyond our control. Whether one is heading toward us or not is something we may never know until it is too late. The fate of a runaway supermassive black hole is one of the greatest mysteries in astrophysics. Once ejected from its home galaxy, it becomes a cosmic vagabond, drifting through the void. The universe is a vast, largely empty place, and in many cases, a rogue black hole may simply travel for eternity without ever encountering another significant mass. But if it does approach another galaxy, its presence could have profound consequences. When a supermassive black hole enters a new galaxy, it doesn't just slip in unnoticed. Its gravitational pull disturbs everything in its vicinity, tugging on stars and distorting the delicate balance of orbits that have existed for billions of years. If the black hole moves fast enough, it may pass right through, leaving behind a wake of gravitational chaos. But if it slows down and becomes trapped by the new galaxy's gravitational field, a collision with the central black hole of that galaxy becomes inevitable. What happens when two supermassive black holes collide? The process is one of the most extreme events in the universe. As the two black holes spiral toward each other, they warp the fabric of spacetime itself, sending out gravitational waves, ripples in reality that can be detected across the cosmos. These waves were first observed by LIGO in 2015, proving that such cataclysmic collisions do happen. However, when two supermassive black holes merge, the energy released is on an entirely different scale. The resulting event can shake entire galaxies, sending out bursts of radiation so powerful they can be seen across billions of light years. Yet, there's another possibility, one even more intriguing. If the rogue black hole doesn't collide with the new galaxy's central black hole but instead settles into an orbit around it, the galaxy could end up with two active supermassive black holes, each with its own accretion disk. This could create a binary system, where the two black holes slowly spiral toward each other over millions of years, constantly emitting gravitational waves as they edge closer and closer to their final, unavoidable merger. These binary systems are incredibly rare, but they may hold the key to understanding how black holes grow and evolve over cosmic time. But what if a runaway supermassive black hole never finds another galaxy? What if it is ejected into intergalactic space with such velocity that it becomes lost forever? The space between galaxies is unimaginably vast, millions of light-years of near-perfect emptiness. A black hole in this region would have little to feed on. Without a steady supply of gas and stars, its accretion disk would fade away, leaving it as a silent predator lurking in the dark. A black hole in deep space would be one of the hardest objects to detect. It wouldn't produce any light of its own, and unless it passed close enough to distort the light of distant stars through gravitational lensing, we might never know it was there. The possibility that such objects exist right now, completely invisible, is both fascinating and terrifying. These are celestial wanderers, moving in unpredictable paths through the cosmos. Some may be harmless, doomed to drift in empty space forever, but others could be heading toward galactic civilizations, waiting to unleash destruction. Even though the concept of a runaway supermassive black hole seems like something out of science fiction, it is a reality that astronomers are only beginning to study in detail. In 2023, observations from the Hubble Space Telescope provided the strongest evidence yet of a rogue black hole speeding through intergalactic space. It was estimated to be traveling at 3.9 million miles per hour, fast enough to escape any galaxy's gravitational pull permanently. This means that these objects aren't just theoretical. They exist, they move, and they could be far more common than we realize. The existence of these rogue black holes also raises questions about the fundamental nature of galaxies themselves. If black holes can be ejected, does that mean some galaxies might have once had a supermassive black hole that was lost to the cosmos? Could there be galaxies that formed black holes, only to have them ripped away by gravitational interactions? And if so, what does that mean for the stars left behind? Could an entire galaxy exist without a central black hole, defying everything we thought we knew about galactic evolution? Perhaps the most unsettling thought is that our own Milky Way could experience such an event in the distant future. While Sagittarius A* currently sits firmly at our galaxy's center, the forces of merging galaxies, interactions with other supermassive black holes, or even unknown cosmic forces could one day send it hurtling into the void. If that happened, it would tear apart the structure of the Milky Way as we know it, altering the orbits of stars and planets in ways we can't yet predict. For now, the study of runaway supermassive black holes remains in its infancy. We are just beginning to detect them, just beginning to understand how they move and what effects they have. But the more we look, the more we realize that these objects are not as rare as we once thought. They are out there, moving, growing, consuming. And whether one is heading our way or not, the fact that they exist at all is enough to remind us of how unpredictable and violent the universe can be. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.